Java, a language crafted by the brilliant minds at Sun Microsystems, led by James Gosling, has emerged as a programming giant, captivating developers worldwide. Its charm lies in its simplicity and portability, making it a favorite among developers. Java's platform independence is a game changer. With its write once, run anywhere principle, you can create applications that effortlessly adapt to Windows, macOS, Linux, and even embedded systems. Java empowers you to unleash your creativity without limitations. Imagine a world where you can build robust software that runs seamlessly on any device or platform, a world where your code comes alive, powering applications that revolutionize industries and enhance everyday experiences. Welcome to the world of Java programming. So here I am with another video by Simplilearn, where we'll discuss the basics of one of the most popular programming languages, Java. But before we begin with the video, if you enjoy watching these videos and find them interesting, please subscribe to our channel because we bring the best videos for you daily. Also hit the bell icon to get notified whenever we drop a new video. So let me take you through the reasons why you should learn Java in 2023. Not just one, but there are multiple reasons why Java is so popular and worth learning in today's world. Wide range of applications. Java is a versatile programming language used in various domains such as web development, mobile app development, enterprise software development, scientific research, and more. Learning Java opens up opportunities to work on diverse projects and industries. Platform independence. One of the key strengths of Java is its write once, run anywhere capability. Java program can run on any platform with a Java virtual machine installed, making it highly portable. This platform independence allows you to develop applications that can be deployed on different operating systems without significant modifications. Robust and mature ecosystems. Java has a vast ecosystem with extensive libraries, frameworks, and tools that simplify and accelerate development. Libraries like Spring and Hibernate, frameworks like JavaFX and Play, and powerful integrated development environments like IntelliJ and Eclipse provide developers with rich resources to build robust and scalable applications. Object-oriented programming paradigm. Java is an object-oriented programming language, which means it encourages modular, reusable, and organized code. By learning Java, you gain a strong foundation in OOP concepts like encapsulation, inheritance, and polymorphism, which are fundamentals to many modern programming languages. This knowledge can be transferred to other OOP languages, making learning and working with them easier. Strong job market. Java has consistently been in high demand in the job market. Many organizations rely on Java for critical applications, leading to a constant need for skilled Java developers. Learning Java can enhance your employment prospects and provide you with a stable career path. According to Glassdoor, the average salary of a senior Java developer can go up to 9.5 lakhs per annum with additional cash benefits. The same Java developer can earn up to $116,000 annually in the United States. These figures clearly reflect the high value placed on Java skills in the industry today. So, are you ready to take your career to new heights? The demand for full stack web developers is soaring in today's fast paced world. And now, Simplilearn presents the perfect opportunity for you to excel in this exciting field with our postgraduate program in full stack web development. This comprehensive program will equip you with the foundation to build full stack web applications using the power of Java programming language. From the basics of JavaScript to advanced level concepts like Angular, Spring Boot, Hibernate, JSPs, and MVC, we have got you covered. What else can you expect from this program? This program includes Caltech CTME postgraduate certificate, enrollment in Simplilearn's Job Assist, receive up to 25 CEUs from Caltech CTME. Simplilearn's Job Assist help you get noticed by the top hiring companies. You'll also get to attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by CTME program director. 20 lesson and 5 phase end projects. So let's take a minute to hear from our learners who have experienced massive success in their careers.
Learning is growing and we not only decided to grow together in life but learn and succeed together as well.
I successfully switched my career to full stack Java domain with a 15% salary hike.
And I was able to grab new opportunities in my current organization and also receive a 10% salary hike. Hey, I am Somjit Basu. I am a senior QA engineer at Encora Inc.
And I am Shomi and I work as a senior quality analyst at Doodleblue Innovations.
We started our upskilling journey together with Simplilearn, and certainly we made the right choice.
After our marriage, I had to relocate to Bangalore and take a year gap after working for 5 years. But I decided to restart my career again and make a switch to software domain. So I enrolled myself in full stack Java developer program from Simplilearn.
Seeing my wife's passion for learning every day inspired me to take up a course on Simplilearn as well. I've always been passionate about technology, and learning DevOps was always in my bucket list. When I saw Simplilearn's collaboration with Caltech CTME, I decided to take a course on PG DevOps.
After the course, I not only switched my career to full stack Java development with a 15% increment in the salary, but now also I can work from home since it's a software domain. And being the new mom, that's the best thing one could ask for, to spend time with little one during these early years.
For me, learning DevOps was fun and fulfilling at the same time. Earlier, I had to rely on others at work, but after upskilling myself, I single-handedly can set up the entire blueprint on my codebase alone and get the desired output. And because of that, I could grab new projects in my organization with a 10% salary hike.
We enrolled to upskill ourselves when we were expecting our first child. So upskilling journey with Simplilearn would be undoubtedly very special to both of us.
While doing the course, we did come across a lot of challenges due to the pregnancy, but my wife Shomi was a great inspiration for me as she was handling it all together, and she kept motivating and inspiring me all the way. Moreover, the recorded classes and the weekend class helped us maintain the balance between work and learning.
Apart from work, we love to spend time with our little one. Learning with Simplilearn was quite a fulfilling experience for both of us. We believe that growth doesn't happen overnight, rather it's a journey of several small steps, and upskilling is one of them.
So let's take a look at what we are going to cover in this video. We'll start this video with the history of Java programming, where we'll get to know who and why created Java. Following that, we'll give you an introduction to Java programming. Once we are done with this, we'll start with the most basic concepts of Java, like data types in Java, operators in Java, and loops in Java. Once we are done with these basics, we'll move on and cover objects and classes in Java. Following that, we'll cover topics like arrays and strings in Java programming. Once we are done with all these topics, we'll cover the object-oriented programming concepts of Java, where we'll cover abstraction, encapsulation, polymorphism, and inheritance in Java. So it is rightly said that you can master a programming language only by programming in it. So towards the end of this video, we'll work on a project where we'll create a calculator app using Java programming. So I hope you guys are ready to learn the basics of Java. So without any further delay, let's hand over this session to our training experts.
James Gosling and colleagues at Sun Microsystems developed Java in the early 1990s. This team of engineers called themselves the Green Team and initiated the project for interactive television. A typical example of interactive television would be the real-time voting on the screen in which the user can control the show. However, this technology was too advanced for the industry and was better suited for the World Wide Web. Java was initially named the Green Talk and then as Oak. In 1994, it was officially renamed to Java. The first public implementation was Java 1.0 in 1995. In 2006, Sun released Java Virtual Machine as a free and open source software. In the same year, J2SE was renamed as Java Standard Edition or SE. Major releases involved Java SE6 in March 2006 and Java SE8 in 2014. As of today, Java 8 and Java 11 are identified as long-term support versions. Popular Java-based products like JUnit, Eclipse, Hadoop, and Android revolutionized the IT industry. The biggest internet company, Google, has a huge percentage of its development in Java. Accenture is using Java for most of its clients. Hardware companies like Intel, Symantec, Philips, Thomson are all Java users. Java is also considered the official language for Android game development. PUBG, the latest youth obsession, is a cross-platform game that uses Java as a sourcing language. Since 2007, Java has remained a de facto standard and is controlled through the Java community process. Java has evolved to become the most popularly used language and continues to make remarkable contribution into the field of technology.
And when we talk about the usage of Java, you can use it to build web applications, mobile applications, desktop applications, even command line applications. And at the same time, you can also use it to build complex applications like gaming applications, building microservices, or building distributed computing, etc. Let's talk about the features of Java. So one of the most prominent features of Java is that it's an object-oriented programming language, which means that everything which happens in Java happens around objects. Objects enable the execution of the program. Objects talk to each other to exchange data and messages. We will look at the concept of objects in details in the upcoming lectures. It's a platform-independent language, which means that, again, going back to the previous point of write once, run anywhere, it basically enables the program to be run on any platform once compiled. So once you have prepared your program and you have compiled your program, then your compiled program can be run on any platform. It is a strong type checking language, which means that it will force you to respect the contracts of the variables to the data types. For example, if you have created a collection which should accept strings, then you can only insert strings in that collection and it will not allow you to add a number or an integer into that collection. So it's a strongly type checking language. So when you run your program, it's a two-step process in Java. You compile the program and then you execute the program, which we also call as interpretation. So you have a Java compiler and you have a Java interpreter. You first compile your program and then you run the program using the help of Java interpreter. Java also provides automatic garbage collection. It's a really important feature. And if you talk about the languages prior to Java, like C or C++, they did not offer this capability. And this capability made Java really popular because it could automatically find the unused objects and variables and remove them from the memory to free up memory space for the program execution. It also provides multi-threading support, which means that you can build multi-threading applications like a gaming application. If you take the example of a racing game, for example, so there can be one thread which is monitoring your leaderboard score. There can be another thread which is displaying the speed of the car. There can be another thread which is displaying the graphic. There can be another thread which is displaying the sound. So you see all of these threads are working parallelly, and Java provides the support to create such applications using the multi-threading capability it has. Java is secure by default because there are no pointers in Java, so there are no possibilities of having any memory leaks or any reference leaks from the application. Again, if you take the example of programming languages like C or C++, you had the concept of pointers, and we witnessed a lot of scenarios and a lot of incidents where there was a memory leakage happening in the production application, which was really a bad experience for the organizations. So Java removed the concept of pointers totally from its programming language. It's also a very robust language because it provides a really great exception handling framework out of the box, which developers can use and implement to build really resilient applications. So now let us understand how a Java program is run. So at first you basically write your Java program and you store your Java program into a .java file. Then you compile your Java file with the help of the Java compiler. Once the program is compiled, the compiler is going to generate another file, which is a .class file. And this .class file is basically the compiled file, or also known as the bytecode file. So this bytecode or the .class file code can be run on any platform, be it a Linux platform or a Windows platform or a macOS platform or any other platform. To give you some more context, the first two steps where you write your Java program and you compile your Java program can be run on any machine. Let's take the example that you ran these two steps on a Windows machine. So you write your program and you compile your program on a Windows machine, which generated a .class file. Then you transported this .class file to a Linux machine and it also worked there. You transported your .class file to a macOS machine and it worked there as well. And that's what brings the platform independence concept of Java, that you can write the program once on any platform, and once you have the bytecode available, then you can run this program on any other platform of your choice. Okay, so that was about how the Java program execution works and how the platform independence is actually achieved. Now let us spend some time to understand the anatomy of Java. So once you download Java and install Java on your local machine, you will hear the term JDK. Actually, if you will see that in the next lecture, that when you try to download the Java, it will say JDK download. JDK stands for Java Development Kit. So the Java Development Kit is the installation of the Java. This is what you're going to install on your machine. Once the JDK or Java Development Kit has been installed, the JDK will provide a lot of other components as well, like Java Runtime Environment or JRE, Java Virtual Machine or JVM, some class libraries, and some other supporting libraries. So let us understand what happens when your program is run and how these components work together to make sure that your program runs as expected. Let's start from here. So you install JDK or the Java Development Kit, you write your program, and then you compile your program with the help of Java compiler, which is provided by JDK. Once the program is compiled, your .class file will be generated, and then you can run that .class file using JRE. In fact, if you just run your program on your local machine, JRE will automatically kick in and run your .class file. So the Java Runtime Environment or JRE runs your .class file with the help of these three components. Let's talk about first component, which is Java Virtual Machine or JVM. So the Java Virtual Machine is actually the virtual environment inside which your program runs. This is the real main environment inside your .class file is running. So when this program is running, how does it achieve this environment? For achieving this virtual machine environment, it would need some runtime libraries, and that is provided by these class libraries. For example, there would be a runtime jar or rt.jar as a shorthand, which will be supplied to the program at the runtime to make sure that the program runs smoothly. Then there are other supporting libraries as well, which your program may be using. For example, if this program, this .class file is, let's say, a calculator program, then it might be using a square root function from java.math package. So how does the java.math package get supplied at runtime? It would be supplied by the other supporting libraries which are present inside JRE. So JRE will make sure that your program runs inside the Java virtual machine. It gets the required runtime libraries, and it also gets the libraries which are referred in your program at runtime. And this all together will make sure that your program is running. So you can see JDK basically provides JRE automatically and JVM automatically, but you can also install JRE separately. If you talk about that use case where you compile your program on a Windows machine using JDK, and then you exported your .class file to another machine, and there you just install the JRE. You don't install JDK there, you just install the runtime environment, and you can run the .class file just using the runtime environment.
So now let's download Java. Let's go to Google and search for Java download. We'll go to the link we see here, oracle.com. So now here we have the web page. Here we can see Java SE 13. So this is version 13, but this isn't the one we are going to download. We're going to download the 8th version, version 8, which is here. Now we're doing this because 8 is one of the more commonly used versions of Java. So let's click this, and here we'll go down. We need to accept the license agreement before we can download it. Now we have two versions here, x86 and x64. Now you can download it depending on what version your operating system is. Now if you do have a Windows 10 operating system, it's highly likely you have a 64-bit version of Windows. Now if you do have a 32-bit version of Windows, you can take the x86. So let's download this. So we've actually already logged in, so we just need to run the installer file now. Let's go to downloads and run the file. So here we have the installer. We'll go to the next step. We'll select this to next. Here we can see where the file is being installed to. We'll go to next. Now if you want to change where you want to install Java, we can press the change option. I'm just going to keep it here. We'll press next and let's commence with the installation. And there we go. The installation is now complete. So we don't need any tutorials or API documentation. So we'll just finish off and go to close. Now to see if Java is installed in your system, we can go to command prompt and type the term javac, which refers to the Java compiler. Now as you can see here, this shows a number of different options you can choose from. This also indicates that Java has been successfully installed in your system. Now if the installation was not successful, you'll see something like javac is not recognized as an internal or external command, operable program or batch file. But since we've done it successfully, this is what will be shown. Now we're going to set an environment variable. Now what exactly is an environment variable? Now assume you have a file which has a .java extension. This environment variable tells the computer that the Java program needs to be called to run this particular file. So to set the environment variable, we'll need to go to control panel. Here go into system and security. Go to system and select advanced system settings. And then this shows up. Now before we go into environment variables, we'll need to go to where the Java file was installed. So let's go to this PC, C drive, program files, and here let's go to Java. So let's go to JDK, which is the Java development kit. Let's go to bin here and copy this path. We'll go back to environment variables, select path here, and then press on new, paste this, and OK. Now we'll go back and go to JRE, to the path of JRE, which is Java runtime environment. We click on this, bin again, and copy this path. Select this one, new, and paste that. And there we go, the environment variables are now set. Now let's talk about running that simple program I told you about. Now this is possible with the help of an IDE. An IDE or integrated development environment will give us a platform to code Java. We will be using Eclipse and IntelliJ as they are popular and commonly used. That being said, there are several other IDEs that are available in the market. So now let's work with Eclipse. Let's go to Google and search for Eclipse. We'll go to this link, press download, and then this shows up. Let's click on download. Now we've already downloaded the software, so I'm just going to directly go into the install phase. Downloads and select Eclipse. With this, you can see that there are multiple options for you to choose from. So we're going to select Eclipse IDE for Java developers. Now you have other options like for C and C++, JavaScript, PHP, and so on. But let's go to the first one, and here you have the details. You can change them if you want, but I'm just going to go ahead with installation now. Press accept now. Here we remember accepted licenses and press accept. And then here as well, we'll remember accepted certificates. Select this one and accept selected. And there you go, the installation is now complete. Let's click on launch now. So here we are setting up a directory as a workspace. I'm not changing it here, so I'm just going to go with launch. Here we have the Eclipse workspace. Now let's close this first. And here we have the package explorer. Now in case this doesn't show up, you can go to window, show view, and select on package explorer. So now let's go to file, new, and Java project. We need to set up a project name. I'm going to call it my project 1. Go to next. We'll go to source. So this is where the source code for your program is going to be stored. Then let's finish. And now we'll click on my project 1, go to source, right click, new, and create a class. I'll name the class my class and create it. And here we have it. So now let's write a simple program to multiply two numbers. So now let's write the main function. Open a bracket. Now we're going to initialize the first number. Now the second one. And finally the output. And finally the variable that will store the output. Now we'll just give them a simple print statement. Now let's run the code by clicking this option here using myclass.java. And there we have it. Here the product is shown to be 100, indicating that the program is running successfully. Now we're done with Eclipse. Now let's move on to the other IDE I was talking about, which is IntelliJ. So for that, again, we'll have to go back to Google so that we can download it. Search for IntelliJ download. Go to this link here. So here you can see that we have two options, the Ultimate Edition and the Community version. Now here the Ultimate version has way more options, as you can see here, but it's a paid version and only has a free trial. Now the Community version is free, so that's what we're going to take. So we'll click on download here. So I've already downloaded the software, so I don't need to do it again. So I'm going to go to downloads, and so here we go. Let's just click on next. Select the location where you want to install it. Press next. Now we will add a 64-bit launcher shortcut on the desktop and create associations. So basically this means that these are the different file extensions that this will support. So .java, .groovy. And now let's go to the next step. We'll install now and we'll wait. And there we go. The installation is now complete. Let's not import any settings. We'll accept the privacy policy. We'll set defaults. Now let's create a new project. So here make sure your project SDK is set to the version of Java you've installed. Make sure this isn't blank. We'll go to next. Here you need to select this option, which is the create project from template, and we are now going to create a command line application. Press next. Name the project, which I'm going to call my project 2. You can change the location if you want. I'm just going to keep it the way it is, and then click on finish. So now we're going to create a simple program through which, based on the user's input, we can determine whether a number is even or odd. So first we're going to import the package scanner through which we can take the user's input. Next, let's go inside here. Let's create the variable reader. Now let's ask for the user's input. Enter a number. We're taking in the value now in the variable num. Reader dot next int. So this is with which we'll be taking in the value from the user. So we're going to set up a condition to determine whether the number is even or not. So if the number when divided by 2 provides the remainder 0, it indicates that it's an even number. We'll show them then. Now for the else case, the number is not even. Or in this case, odd. There we go. We're done. So let's run this program. So let's enter 12. The number is even. And there we go, we have a successful output. This indicates that the program is running successfully.
So let's learn about the data types now. So Java has these primitive data types, which you can see here. Some of them store numbers, some of them store Boolean values, and some of them store characters. So the data types which store numbers are byte, short, int, long, float, and double. These 6 data types basically are used to store any kind of numeric value. Let's understand these a bit more. Byte is the shortest possible data type value which you can use in Java to store numbers. You can only store numbers within the range of -128 to +127. So you can see the range is very small, and Java has created this variable for use cases where you want to store numbers which have very small value in this range. Why do we provide these kind of options? Just to save memory, because the smaller data type will require less memory to be used in the Java program. Similarly, the next bigger data type is short, which is a bit bigger than byte. And the range of this particular data type variables will range from -32678 to +32767. So that is the range for this particular variable. And you can see that it has a very big range as compared to the byte data type. So if you want to store values which lie in this range, you can use short. The next one is int data type. You can use this one to store even larger values, which range from -2 raised to power 31 to +2 raised to power 31 minus 1. The next one is long, which is even bigger than int, and it can be used to store the values within the range of -2 raised to power 63 to +2 raised to power 63 minus 1. So as you can see, as we go from top to bottom, from byte to long, the size of the value which can be stored using this data type increases. And that's how you will basically take a decision of whether you want to use byte or you want to use short or int or long, based on what size of the value that variable is going to contain. Then the next ones are float and double. These two have been created for the use cases where you want to store the values, numeric values, which have decimals, which are precision values. I should also mention that byte, short, int, and long are only used for storing absolute numbers which do not have any decimal representation. Even if you try to store a decimal value in these variables, they will automatically be trimmed. The decimal values will automatically be removed, and you will only be shown the absolute values. And in case of float and double, they can maintain those precision and decimal values. So we use float for the use cases where you want to store decimal representations of the values. And you can see that the float value can store a smaller precision value, but double can store even a bigger precision value. So if you have really big precision values to be maintained, very big decimal values to be maintained, you should use double. And the float is used for storing a bit smaller size of the precision values. I mean, its range of values basically beyond the scope of this discussion. If you want to read more about this, you can go to these particular links, which will explain this in detail. But the basic idea is that float is good for storing two precision values. And if you want to go beyond that, you want to use double. In some cases, some people also use float to store even beyond two values as well. So it completely depends. The decision factor is how long the value you are going to store in the decimal. And that will decide whether you want to use float or double. The next one is Boolean, which is used for storing the Boolean values. Boolean values can be either true or false. So there are only two possible values. And then we have char, which is used for storing characters. It is using 16-bit to store the value. And this is a very popular Java question for beginner level programmers, that why does it need 16-bit to store the character? It's because it stores a Unicode representation. Unicode representation is the representation which can be accepted across platforms across the world in different character encodings. So let's move on to Eclipse now, where I have prepared a very short and simple demo. I'm just creating a variable for each data type and I'm printing them. You also see some things here like these keywords, and don't worry about these keywords. I will cover these keywords in detail in the upcoming lectures. You also see this, and you can just, for now, you can remember that system.out.println is used for printing anything in Java. Anything you want to print on the console, you would be using system.out.println. What is system, what is out, and what is println? Again, we will cover these in the upcoming lectures. For now, I'm just creating a bunch of data types here, variables here basically. I'm creating a char type variable, a byte type variable, a short type variable, an int type variable, a float type variable, a double, and a boolean. The way you create variables is basically you put the data type name, you put the variable name, which can be anything, you put an equal sign, and you put the value, actual value which this variable is going to store. And I've done the similar thing for all of these variables. Java wants semicolons to be there when you write your statements. So please remember that your statements always end with semicolons. So I've declared all of these variables here, a byte, a short, an int, float, double, and boolean. And then I'm printing all of them basically. Here I'm printing the char variable. Here I'm printing the byte variable. Here I'm printing the short, and so on and so forth. So how do we actually run this application or this program? You just double click on this or right click on this. You go to this run as option. You see this run as Java application option. So you can hit this option. It will run the application and it will present all the output here in the console tab. Let me just bring this up. So you can see all the variables have been printed here, and this is coming from these print statements. Like I said, this is used, system.out.println is used to basically print anything. And I've used that to print all the variables here. First, I'm printing the char variable whose value is A. Then I'm using the byte variable, which is denoted by B and whose value is 2. So you can see the value is 2 here. Then I'm printing the third variable, which is C, which is a short type variable, which has a value 22. You can see short, and this is coming here. The next print statement is int. So you can see int here with the value 45, and this value is coming from here. Then we have float. You can see the float value being printed here, and you can see the float value declared here. You also see an F here, and this is the standard naming convention which Java proposes, that whenever you declare float and double, you end them with F or D based on whether it is float or it is double. Then you see the double value, which is having a bigger precision than float. So I've printed the double value using this particular print statement, which is printed here. And then we have the Boolean value, which is stored as G, and the value of G is true, and the same value is printed here. So whatever I write here basically is printed here. This is just a placeholder, and this is the actual value. So you can see that we are able to use all the variables here, all the primitive variables basically, which range from byte, character, byte, short, int, float, double, and boolean. And the first non-primitive data type we are going to talk about is string. And before I go on further, I should also mention that it's very debatable in the Java community to call string as a non-primitive data type. And actually, technically speaking, string is a special data type. It neither fully lies in the primitive category, nor it fully lies in the non-primitive categories. I'm covering this as a non-primitive data type because it's a bit inclined towards the non-primitive category. Why do we do this? Is because Java does provide native support for string handling in the JDK. And that's the reason some of the developers feel that string is a primitive data type, which is primitively supported by Java. But at the same time, string is so customizable and it's so special in nature. It's the way it stores the value, the way it provides the operations and handlings. It's so different than primitive data types that it cannot fully be put in the same bucket as the primitive data types. So that's why I said it's a special data type, a bit inclined towards the non-primitive category. So what is string basically? We covered about the char data type in the previous lecture, and in char data type, you can only store a single character, right? But if you want to store a complete name of somebody, then it's a list of characters. It's basically a lot of characters together. Then in that case, you would need a data type to store that continuous sequence of characters. And that's what string does. String can store a continuous sequence of characters. Technically, string is basically a character array. You can call string as a character array. And don't worry if you don't understand about the word array. I will explain that in the same lecture. So basically, it stores the continuous sequence of characters. That's how we define string. And you see this string, this is basically the keyword, the data type basically in Java. So whenever you want to create a string, you need to write string with S capital. you need to give a name to the string. This can be anything. And then you can provide the value, which this particular string is going to contain. So you can see this is a continuous sequence of characters. T, E, S, T are the 4 characters which this string is going to contain. And after that, again, I'm printing this particular value. And like I said, don't worry about this. We'll cover this when we'll write our first program in Java. So this is just to print the string value. I'm just putting a string placeholder here, and then I'm actually printing the values of the string variable. Now, string can be created in multiple ways in Java. This is one way of creating it. There's another way of creating a string variable, which is this one, which says, again, the string data type, some variable name, a keyword called new. Again, don't worry about what is this new keyword. We'll cover this when we'll talk about running our first program in Java and writing the first program from scratch. Then we again say string, and then we provide the value. So if I compare this line number 4 to line number 7, you can see the difference is that I'm still storing the same value, test, but the difference is that here there is no new string keyword, but here we have this new string keyword. So what is the difference? The difference is this, that in this case, in this particular case, string is going to reuse the same object multiple times. But in this case, every time you call this, it is going to create a new object. Again, what is object? It's just, you can think of it as, for now, you can think of it as a memory block. We'll again cover objects in details. But these are 2 different ways in which you can create string. This is generally the most popular way of doing it because this is memory efficient, because you can reuse the same variable again and again. So I'm creating the string variable here and creating another string variable str1 here and printing both of them. Then I've created this strange looking thing here, which is basically an array. Array, like I said, is also a non-primitive data type in Java, and array can store a continuous sequence of anything. That anything can be a number, that anything can be characters, that anything can be a floating number as well. So basic idea is that if you want to store a collection or a sequence of multiple values, how do you do that? You do that with the help of arrays. Array is a data structure, a non-primitive data structure in Java, which can store lot of values of similar type. We also call it as homogeneous data structure, because it can only store same data type values or homogeneous data type values. So the biggest way to identify array is this square bracket. Whenever you see this square bracket in Java, it means it's an array variable. So here I am creating an integer array variable with the name ARR. This is the name of this particular array. It is only going to store integer values because I've specified int. And the moment I provide the square brackets, it means that it is an array. So you can declare an array like this, and then you need to assign a size to the array. Size is basically denoting how many values this data structure is going to store. So I'm saying new, again, it's a keyword, and I'm saying that, okay, create a memory block for storing 2 integers. So this particular array ARR can store at max 2 values at continuous locations. The next thing about array is that it stores the value in a 0 index based location. So like I said, it can store 2 values. So the first location will always be array of 0. And this is how you specify the location or index of the element which is going to be stored. So at the 0th location of this array, I'm storing 0. The first location of the array, I'm storing 1. And this is just to show an error scenario, but I will just comment this for now. You can just put double slashes and comment any line. So I'm just filling up this array for 2 values, and the 2 values location would be 0 index and first index. These are just continuous memory locations, and we denote those memory locations as 0 and 1. Array indexes always start with 0, and I'm just putting some values here. You can put any values. And then I'm printing the whole array, and I'm also printing the first value of the array. And we'll see how this pans out, and we'll also see how we can change this. So now we are going to run this application. So I'll just go to run as and click on run as Java application. And once I hit that, I get this output here. So let's understand this output. The first one is I'm just printing the string, which has the value test. And you can see it has printed here. It is coming from this line. Then the next line which is printed is line number 8, where I'm saying another string str1, and str1 also had the same value. So you can see another string has the same value. And then I have printed the array here, the complete array. And you see this strange value here. It also tells us that if you want to print the array, then you cannot just put the variable name and print it. The reason is because this is a non-primitive data type. And once you do this, it is basically printing the memory footprint of this array, the whole memory location where this array is stored. That's why you see this strange looking number, which is the memory hash code. And if you want to print any particular value or any particular element inside this array, then you can do that by providing the index location of that element. So here I've said that print the 0th location element of the array. The 0th location array element of the array was 0. So you can see the value 0 here. Let me put some other value just for fun and show you how this works. So I've just changed the values, and now let's see what do we get for array 0. You can see now I get value 3 because now at the 0th location, the 3 value is being stored, and that is what is being printed here. We can also print the first value. I'll just go run as Java application. You can see now the array of first index is being stored, which is basically technically the second element of the array. But because array always works on a 0 index based value format, that's why when we say array 1, the second element is printed. When I say array 0, the first element is printed. So always remember that array is a 0 index based collection or data structure basically. What happens if I do this? Now there is no third element in this array because the array has the size only of 2 elements. And when I say ARR of 2, which means I'm trying to print the third element in this array, which does not exist. So let's see what happens in that case. I get an exception. Exception is basically an error. I get an error saying that index 2 is out of bounds for length 2. It means that the array length was actually 2 and index 2 does not exist. Remember, it's saying index 2, not the element 2. Index 2 doesn't exist because only index 0 and index 1 exist. This makes 2 elements and the actual size is also 2. It does not have capacity to store third element. It does not have third element location anywhere. That's why it complains that you are trying to print a non-existing value. When we talk about operators in Java, there are multiple types of operators like assignment operators, arithmetic operators, unary operators. Then we have conditional operators and logical operators, and we also have bitwise operators. And we will cover all of these operators one by one. We will understand what these operators are and how they work, and we will also look at a demonstration of it. So let's get started. The first operators we are going to discuss is about arithmetic operators and assignment operators, and we will also see if we can cover unary operators. So when we talk about assignment operators, I have again opened the official Java docs here. If we understand assignment operators, we have been using these operators all the while in all of the demos so far. And the basic idea is very simple. Whenever you assign a value to a variable, you use the assignment operator, which is nothing but the equal sign. We have already covered this in multiple demos, so I will not cover this as part of the demo. But what I'm going to cover in detail is about these arithmetic operators. So arithmetic operators are basically used to perform any kind of arithmetic operation on a Java program. It can be an addition operation, it can be a subtraction operation, it can be a multiplication operation, a division operation, or an operation by which you can find the remainder of the division. So we will look at each of these with an example, and as you can see, the symbols are expectedly what you generally use in mathematics. So you see the plus sign here, which is for addition. You see the minus sign, which is for subtraction. You see the star sign, which is for multiplication. You see the slash sign, which is for division. And you see the percentage sign, which is for finding the remainder of a division. So let's see an example of each of these and how we can use them in a Java program. So for the arithmetic operations, I have prepared a demonstration of it in the Eclipse IDE. Again, I'm using the same Java project which I have shown you we created in our previous lectures. So for all the demonstrations, I will just continue in the same project. So Again, the way to create a class remains the same, exactly the same as how I covered in the previous lecture in the Hello World program where we created a class. So here also I created a class. I named the class as arithmetic demo, and I have a public static void main method inside this particular class, and I have basically tried to demonstrate each of the operation. So let's start with the addition operation first. So I create an integer variable here named as result, and then I try to use the addition operator to make this variable store the result of this addition. So it's a simple 1 plus 2. You can also create two different variables for 1 and 2. Let's say x equal to 1 and y equal to 2. And you can also do int result equal to x plus y. It will have the same effect. But just for simplicity, I have put the literal numbers here. So result is storing the expression value of 1 plus 2. And then I'm printing this value here. You can see I'm printing the result variable here with using system.out.println. Then I'm storing this result into a variable, into a new variable, original result, with using the assignment operator. And then I'm trying to subtract something from it. So now I'm saying result equal to result minus 1. It means whatever the current value of result is, subtract minus 1 from that value. So the value was 3 here, and here 3 minus 1 becomes 2. So the new value of result becomes 2. The original result still holds 3 because it is storing the old value. The new value of result has now become 2. So I'm printing the original result, and then what I'm doing, that I'm again assigning the new result, which is 2, to the original result. So now original result and result both are at 2. Then I move ahead and I try to demonstrate the multiplication operation. So I take the same variable result and I say multiply it by 2. So whatever the value of result was, which at this place should be 2, multiply that value by 2. So 2 into 2, the new value of result should become 4 after this multiplication operation. And again, I'm assigning the value of original result to this particular variable. And then I'm showcasing the fourth mathematical arithmetic operation, which is division. So you can see result by 2 here. So basically, whatever the current value of result is, I'm dividing that value by 2. So 4 divided by 2 should become 2. So again, the new value of the result variable should become 2. Then I'm printing the value and again storing the value back into the original result. Then the next operation is again an addition operation where whatever the value of result is at this particular point, which is 2, add 8 to that particular value. So the new result value becomes 10, and then I'm printing that particular value, again assigning the original result to the result. And then to showcase the remainder operation, I'm doing result. We call this particular operator as mod or modulus. So result modulus 7. So the current value here is, in this case, would be 10. So I'm saying 10 mod 7. So 10 mod 7 would become 3, because if we divide 10 by 7, the remainder should be 3. And this modulus operator is used to calculate the remainder of a division operation. So that 3 will be stored in this result variable, and then we print that particular variable. So that is what I'm doing. If I take you back up there, I'll just minimize this window and this window as well. So if I take you back to the starting, I'm doing an addition first here at line 7. Then I'm doing a subtraction at line 12. Then I'm doing a multiplication at line 17 and a division at line 22, and then again an addition at line 27, and then a modulus at line 32, and I'm printing the respective values. So let us run this program and see what results do we get. So I right click, I go to run as, I go to Java application. There is also a shortcut for it. If you want to use the shortcut, you can use that. So I click on this and the output is displayed here. So you can see, let me bring this output back to its original position. Yeah, I just dragged it here to the top, to the bottom. So if we start from the top and see what all results did we get printed. So line 9 says 1 plus 2 equal to the value of result. So 1 plus 2 equal to, at this particular point, the result value was 3 because 1 plus 2 equal to 3. Moving on, the next variable here is minus. So the current value was 3. We said 3 minus 1, which becomes 2. And we store the value of result or 3 into this result variable, and we print that value at line 14. So original result plus original result is 3. Then a string here -1 equal to, so this is just a string, and then the actual current result value, which is 2. So far so good. We move ahead, and then at line 19 we are multiplying the current value of result by 2 and again displaying the original result and the current value. So 2 is the original result here, because here 3 minus 1 had become 2. So original result value was 2. Multiply that by 2 becomes 4. Then moving on to the line 24, 4 by 2 should become 2. So 4 by 2 equals 2, the current value of result. Then again moving on to the next variable, at line 29, now the result value should become 10, because 2 plus 8 is 10. And again we are printing the original result and then the current result value. So the original result was 2, then we added 8 to it, and the new result value had become 10, which is coming from this particular variable. Moving on to line 34, we are again printing the original result, which was 10 here, and then we are saying this particular string, which is modulus 7, and the current value of result is coming from this expression, which is 10 modulus 7. And like I said, modulus or mod operation is basically used to calculate the remainder of a division operation, which, so 10 divided by 7, remainder is 3. So that becomes 3, and that's why you see the value 3. So this is a demonstration to show you how we can use the addition, multiplication, subtraction, division, and modulus operators, which are all the arithmetic operators. And I think this is where we should stop this lecture. So in the next session, we will be discussing about the other operator types, which are unary operators, and we will also discuss some other interesting operators which are popularly used in Java.
So, are you ready to take your career to new heights? The demand for full stack web developers is soaring in today's fast paced world. And now, Simplilearn presents the perfect opportunity for you to excel in this exciting field with our postgraduate program in full stack web development. This comprehensive program will equip you with the foundation to build full stack web applications using the power of Java programming language. From the basics of JavaScript to advanced level concepts like Angular, Spring Boot, Hibernate, JSPs, and MVC, we have got you covered. What else can you expect from this program? This program includes Caltech CTME postgraduate certificate, enrollment in Simplilearn's Job Assist, receive up to 25 CEUs from Caltech CTME. Simplilearn's Job Assist help you get noticed by the top hiring companies. You'll also get to attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by CTME program director, 20 lesson and 5 phase end project.
So first of all, understand why do we need loop statements. So generally, whenever you are dealing with some data structures in Java, which can store multiple elements, for example, we saw array, which can store multiple elements. String is also basically technically a character array, which is storing multiple characters. So whenever you have these kind of data structures where you have multiple elements being stored in the same then in that case, you would like to have a way to iterate or access all of the elements in a seamless fashion. One of the ways is to access them individually one by one, but that's too much of work. That's too much of code. There has to be a simpler way of accessing all the elements one by one if I want to. And that's where the majority of the use cases for using loops coming to picture. Now, Java provides multiple constructs to write loops in Java. There is a while loop, there is a do while loop, there is a for loop, there is also an enhanced for loop. And in the previous versions of Java, a use case of iterator was also very popular. So there are multiple ways in which you can actually iterate over a collection and access all the elements of the collection one by one. And you can use it to multiple useful cases. For example, if you have a huge array of employee salary and you want to give bonus to each of the employees and add the bonus to the salary, then you need to do this addition for all the employees. It would be nice to have to return a while loop, and the while loop can automatically access all the employee salary one by one and keep adding the bonus to the salary. This would be an easier way to do this rather than individually updating each employee's salary. And the first loop statement we are going to understand is a while loop. So the syntax of while loop is very straightforward. You write the while keyword, you enter the actual condition which will be evaluating to a boolean true or false. So you write the expression which will be a boolean expression, exactly similar to the conditions which you use to write in your if statements. So you write your condition which will evaluate to either true or false, and then you write your statement, and these statements will keep executing till the time this particular expression evaluates to true. So generally the way it works is that it will enter the while block, it will evaluate the expression. If the expression becomes true, then the statements inside this particular while block will be executed, and after the execution of the statement, it will again go back, again evaluate the expression. We call them steps basically. So it will go to the next step, again evaluate the expression. If this still holds true, it will again go inside, execute the statement, move on to the next step. It will again go to the evaluation. So this loop will continue to go till the time this condition will hold true. If it still doesn't make sense for you, don't worry, we will have a demo of it to make you understand how to use the while loops. And maybe it's a good idea to switch to the IDE and look at an example of it. So I have already created while demo for it. Here it is. It looks very small and simple, but it will get to the point where we can understand how and why will we be using the while loops. So I've created a while demo class. I've added a public static void main method here, which is the entry point. I have declared a variable which is int count equal to 1. So the count value is 1 right now. And then I'm writing a condition here. I'm saying while count is less than 10, do this. So it will print the current value of count. And after that, I'm using the post increment unary operator. If you remember, we covered this in the previous sessions. What is the meaning of this? It basically will increment the value of count by 1. This expression is equivalent to if I write it in this way. If I write count equal to count plus 1. This is exactly the same as this, no difference. So this will have the same impact. I will just remove this line because we already have the count plus plus here. So if we try to understand this, we are basically incrementing the count and then checking the condition again. So at first time, it will be 1 less than 10. Yes, that is true. It will go inside and print the count value, the current count value, which will be 1. And then it does count plus plus. So now the count value becomes 2. It will again go back here, again check the condition saying is 2 less than 10? Yes, that is true. So the while condition again becomes true. It will again go inside this, print the current value of count, which is 2, then do count plus plus. So it will again increment the value of count. So now the count value becomes 3. Again go back here at condition and saying is 3 less than 10? Yes, that is still true. Again come here, print the 3. Again go here, make count as 4. 4 less than 10, prints 4. Again count plus plus, count becomes 5, and so on and so forth. It will keep doing that till the value becomes 10. So at a step when count plus plus results in the count value being updated to 10, it will go here and say is 10 less than 10? Now that is not true because 10 is equal to 10, but 10 is not less than 10. So this condition will become false and it will exit of this while loop and it will come here and it will execute if there was anything written after the while loop that will be executed. So that's the idea, that you want to do something till a particular condition holds true. Then you can use the while loop, define your condition and execute the statements and try to do something which changes the state of this condition. Here I'm changing the count so that every time a new evaluation happens. If I comment this, this will result in an infinite loop because 1 will always be less than 10. I will not be incrementing the count here and it will keep running forever. It will never stop. It will just keep printing 1, 1, 1 every time till your computer program runs out of the memory. So always remember not to end up into an infinite loop. That's probably one of the biggest mistakes any beginner programmer does. So please try to be aware of that particular loophole, not try to run an infinite loop. Always try to write something in the code block which can change the state of the condition, and also make sure that that state condition sometime should become false. You should also make sure that that always becomes false, because if I do this, then this condition will always remain true because it is already 1, then it will become 0, then it will become -1, -2, -3, so on and so forth. But that value of count will forever be less than 10. And again, you will never be able to exit this loop. Your program will be stuck in this loop till your program runs out of the memory. So always remember to write a statement or a statement of execution in your code block, which can change the state of the condition, which results in some eventual time when this condition becomes false. This condition has to become false eventually, otherwise you will never come out of the loop. Always remember that. So if we run this program now, let's observe the output. So we can see here this particular statement is printed for 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. After 9, the moment the count plus plus resulted into the count value becoming 10, it checked that condition and then it just came out of the loop because 10 is not less than 10 and the condition became false. So always do something inside your code block which results at least of one scenario where this condition becomes false. And that is how you can use the while loop. Now you can see this is a pretty generic code and you can write any kind of condition here, write any code you want to execute here, and then do something to change the state of the condition as well in a positive way, in a way which results this particular condition to be false at some point of time. And then your while loop will run fine. So this is all I wanted to cover in terms of the while loop. Hello guys, let's get started with today's topic, which is about how to use do while loops. So let's understand when do we need that and how do you actually use that. Let me switch to the Java documentation and if I can find some syntax of it as well. Yep. So as you can see here, if I just highlight this portion, this is how you actually write a do while statement block. So you write do, you start a code block, you write some executable statements, and then after the code block ends, you write a while expression and end it with semicolon. This is the syntax basically. It starts with do or curly braces, some executable statements, a while block or a while statement basically with an expression ending with a semicolon. Let's understand this with the help of a program to understand the structure better. So for this, I have created a sample program here, which is called do while demo. Again, having a public static void main method, and it has a variable which is count and it is initialized as 1. Then I write do, I write this code block or the curly braces, and then I am just printing the value of count. Then I am incrementing the value of count, and then I am writing a condition which says while count is less than 10 and semicolon. If you compare this with the previous demo we ran, if I just put them side by side, we had while condition statement and the state change condition. Here we have do statement, condition change statement, and then we check the condition at the end. So the idea is that if you have a use case where before you even evaluate the condition, you want to print something, even before you evaluate the condition. If you want to do something, in that case, you will use the do while loop. Even before the actual while loop starts, if you want to execute a statement, you will use do while loop. For example, if you want to print the initial value of the count even before the condition checks, then you can use do while loop. If that is not your use case, you can use a simple while loop, which is described here in this program. So coming back to the do while, so I say do, and then I'm saying print this particular statement without checking anything. This condition will be executed for the first time without any condition check at all. This will just work as is, like a normal Java statement. After that, I'm incrementing the value of the count, and then I'm checking the condition. So remember, when this particular condition is being checked, the first increment has already happened. But in the while case, we did the comparison before even the first increment. The first comparison happened with the original value of count. But here, the first comparison is happening with the incremented value of the count. Hope you get the difference in a better context now, that you will use this when you want to write some initialization code before you actually hit the condition. So this condition will be evaluated with 2 less than 10, and then the value will be printed. Let's print this example, and we'll also try to play around with this example a bit more to build our understanding better. If I run this program, there is no difference in output if you compare this with the previous program we ran for the while. So it prints the count value. So this is coming here. Then it increments the value. Then it checks the condition saying is 2 less than 10. Yes, that holds true. If that holds true, it will go back to statement number 9, again print this, again do an increment on the count, and again check the condition with the updated value of the count, which will say 3 less than 10 now. Similarly, print the value, increment, check. This will continue to happen till this particular condition becomes false. And once this condition is false, it will exit out of this whole do while loop and it will go to the line number 12. And if you have any statement written there, you can that statement will be executed in this case. So let's try to change some values here and let's see if we can make sense of this program if we change the value. Let's say if I put 11 here, what will happen now? Let's run this program. You will say now you will see that this particular output is displayed which says count is 11. So what happened here, that count was 11, it entered the do while block, it went to this particular statement which said count is 11, then it incremented the value, so the value became 12, and obviously 12 is not less than 10, so it did not print it again. It only printed once, even if the first time the condition was checked, the first condition execution itself resulted in false. Still, line number 9 got successfully printed. And that's the whole idea behind using the do while. What if I change this value to 10? Let's see what happens. And after that, we'll run one more combination to just make it more interesting. This time again, count is 10. Line number 10 will be printed as count is 10. Then at line number 10, the count is incremented to 11 and 11 is not less than 10. So in this case, the loop ends and it will move out. Now, what happens if I do this? If I say less than equal to here, let's run this program and interpret the output. Now, again, only one statement is printed because in this case, the count is 10, 10 is printed here, and we are saying 10 plus 1, 11. 11 is still not less than equal to 10, and that's why the loop just exits. Let's make it 9 and see what happens. Now you see two values. So count is 9, it enters the do while loop, goes to statement number 9, prints the current value of count, which is 9, then increments the value to 10. Then at line number 11, this while statement is executed and the condition is checked. Is 10 less than equal to 10? Yes, 10 is not less than, but 10 is equal to 10. So this condition will hold true. It will go back here, print count is 10, make count 11, again check the condition, is 11 less than equal to 10? No, it's not. And then the condition will return to false and loop will be exited. So hope this will give you a better understanding now, since we ran different permutations and combinations of the values and we saw when this will be executed and when this will not be executed. But the bottom line is very straightforward, that whenever you want to write some pre-processing logic, even before checking the very first condition of your loop, then in that case, you will be using a do while loop. Otherwise, a normal while loop or a for loop will absolutely work fine. Hello guys, let's get started with today's topic, which is about for loops in Java. So far we covered about while loops and do while loops, and we also saw different examples of using different types of data structures like arrays. But one of the core requirements whenever you are working with any kind of collection is to iterate over it. Exactly similar to what I explained in the do while and while lectures, that you would often require to iterate over a collection or a data structure. And for that, one of the most sophisticated and easiest way to do that is using for loops. So let's understand the syntax of for loop first, and then we will also look at an example of it in the Eclipse IDE. So I have just opened the official Java docs here. So if you see, this is basically the syntax of a for loop statement. So let's understand it. And let's also try to compare it with a while loop so that we can understand how it compares with the while loop. So if we see the syntax, we first see the term initialization, then we see the term termination, and then we see the term called increment. Now, if I try to compare it with a while loop, there also you basically did these three things. You first initialized a variable outside the while loop, which is called initialization. And then you wrote a condition, which is your termination condition. You wrote a condition saying, let's say, while I is greater than 10 or while I is less than 10. So that is the condition, which is also the termination statement. The loop will continue to execute till that condition evaluates to false, and that's when the loop terminates. That's why we call it as termination. And then the third piece of it is the increment, the I++, which we used to do in the while loops. So these three portions together make or constitute any kind of loop in any kind of programming language. And for loop, if you see, the kind of code which you use to write in a while loop in multiple lines, where you first initialize a variable, then you write a condition in the while block, and then inside the while block, you use to increment the variable. All of that can be done in a single line in the for loop. And that's why I said it is the most sophisticated and easiest way to write loops in Java. So you write all of these three things, the initialization, the condition, and the increment or decrement values in the single line. And then you start with the curly braces and you write the code which you want to keep executing till the condition evaluates to false. That's the basic syntax of it. So let us try to understand this with the help of an example. So here I have opened a class which is called for demo, and this is a class which will demonstrate the usage of a for loop. So again, we have a public static void main method, which you can see here, which is the entry point. And then I use the keyword for. I put standard braces or the brackets, and then I do the initialization. So this part is the initialization part. You initialize the variable. So I just say int I equal to 1, initialization done. You end it with a semicolon so that it is a single statement understood by Java. And then you write this condition, which is your evaluation / termination condition. So this condition is basically the deciding factor of how long your loops should run. It's exactly similar to what you used to write in the while block. If I just show you the example, this is what we used to do. So we did the initialization at line number 7. Then we wrote this termination condition inside the while syntax or the construct. And then we did the increment here. So we are doing all of these three steps, but we are doing it in a single line. So this is the condition, and then we write our increment or decrement values, which are going to change the evaluation condition every time at every step. So we are saying I++. So technically what I am saying here is that start with I equal to 1 and then check the condition I less than 10. So in the first step, it will be checking if 1 is less than 10. If the condition holds true, go inside the for loop, execute the statement at line number 7, and then go back to this particular statement. So we do I++. So I becomes 2, and then you again go back to the condition. And again you check if 2 is less than 10. Yes, it is. So again you go inside the for loop and do whatever is written there. There can be multiple statements here. For now, I have just written one system.out.println. So that happens. And once all the execution is finished inside the block, it will again go back to the increment. Does the increment, so 2 plus 1 becomes 3. Again does the evaluation. And if the condition holds true, it will again go inside. So this will continue. This condition checking, execution, and increment will continue till the time this condition holds true. The moment this condition becomes false, the control will come out at line number 9. So that's the basic anatomy and control flow. It's very important to understand the control flow of a for loop. Otherwise, you might end up into a program which is forever running and which will just eat up all the memory available in your JVM. So be very sure of what you write in your for loop. Be very sure of especially these two parts, the condition and the increment or decrement. So this is very important piece. The initialization happens only once, and then this condition evaluates. If the condition holds to true, some code executes, goes back to the changing statement, which can be an increment, decrement, whatever, and again compares the updated value with the condition. So this will keep happening. Let's run this code to interpret the output. So I will right click, go to run as Java application. And if I interpret the output here, I can see that it started with count is 1, 2, 3, 4, 5, 6, 7, 8, and 9. it stopped at 9. So what happened there? Let's try to evaluate the termination condition. So let's say I has become 9 and 9 is less than 10. So it goes inside and it prints count is 9, which is I. Then it goes here and it says 9 plus 1. I plus plus means 9 plus 1, the current value of I plus 1. It becomes 10 and then it again compares the condition. So now 10 is not less than 10. 10 is equal to 10, but it is not less than 10. So the condition becomes false and count is 10 is never printed because this condition has become false. It will jump out. So let's say if I do this, if I put an equal to here, and if I now execute the same program, this time I will see 10 here. And because I have said that, okay, check the condition, if 10 is less than or equal to 10, that will become true. It will print count is 10. Then it will increment and the count will become 11. The I will become 11. And then it will check 11 is less than or equal to 10. No, it is not. So condition becomes false and the control comes out of the loop. So that's how you should always try to interpret the loops. You can also run some infinite loops. For example, if I say I equal to 1, I leave it that, and I say I minus minus. So what happens? I equal to 1, 1 is less than 10. Yes, it goes here, prints the value, and then I decrement the value. I don't increment the value, I decrement the value. So whatever value comes out will always be less than 10, and this loop will run forever. For fun, let's try to run this, and I will have to kill this program manually, but just to show you what happens and what you should not do in your Java program. So you see, it will continuously keep printing the values till the program runs out of memory, till it eats up all the available memory. It is forever running. It will never stop because the condition will never evaluate to false. This condition will forever be true. So the loop will run forever. So I'm just going to kill the program, but this is something which you should avoid whenever you are writing Java code. And this happens quite often with beginner programmers. Hello guys, and let's get started with enhanced for loops in Java. We generally use the enhanced for loops for scenarios whenever we have to iterate over a collection of items or an array of items. Those are the most popular and common use cases of using enhanced for loop. And this for loop is even simpler. Like I said, it's even simpler than writing a classic for loop. And the syntax is simply like this. You again start with for, put the standard brackets, and then let's start from the rightmost because then I will be able to explain it better. You specify the collection in the rightmost side of the bracket. The collection can be an array, it can be a list, it can be a map. So whatever different kind of collections which are available in Java, and we are going to cover collections in detail. So don't worry if you don't understand what are lists and what are maps and what are sets. We will go into detail of each of these one by one in the upcoming sessions. But the idea is that you put the collection to the rightmost, then you put a colon, and then you put a representation of the member of this collection. So for example, here this numbers is basically an int array. So this int array means that this array can only hold integer numbers, and that's why we write int here, because this array is only having integers. Then we put any placeholder variable name. This can be anything. You can even write it as I if you want to. You can write it as anything, any variable name which you want to write. This is a temporary variable. So now this code is going to execute in a manner that it is going to iterate over this array one by one, starting from the first element, going till the last element. You don't need to write any initialization code. You don't need to write any termination condition code, and you don't need to write any increment or decrement code also. And how these three values are actually taken care of, let's understand that as well. So when we talk about the initialization, as I have put an array here, a data structure here, the automatic initialization index is going to be the first index. So when we do the iteration, when this for loop is going to execute, it is automatically going to initialize a temporary variable with the value at the first index, which is the index 0. As you know that array is a 0 index based structure. Then comes the condition part. So the condition evaluation is going to be again based on the size of the array or the size of the data structure which you are using. It is going to start from the first index, which is the index 0, and it is going to iterate till the array's last element is reached. So technically start from the index 0 and go till the last element. That's your evaluation condition. And then comes the increment part. So at each step after it has successfully accessed the first element, automatically the index is going to be updated to pointing to the next element. So if it starts from here, once the first step iteration is complete, I is automatically going to be incremented to index 1, and then it will basically, this I will be holding 2. Then in the next iteration, the same I is going to be holding 3. Similarly, I will keep holding the new value of the collection item one by one till the collection item's last element is reached. So this is the basic premise, that you can write a collection variable here and keep iterating over it, and this whatever variable you write here will hold the current item's value one by one. So in the first step, this I is going to hold 1. In the second step, this I is going to hold 2. In the third step, this I is going to hold 3, and so on and so forth. That's the basic idea. So now let's run this program to see what kind of output do we get. So you can see we basically are able to print all the elements of the array. And that's probably one of the most popular usage as well, that if you want to just print all the elements or access all the elements of a array or a collection one by one, then just use enhanced for loop. So you can see at each step, it is printing the value of I, and the value of I is basically the subsequent elements of the array. That's the whole idea with enhanced for loop. Under the hoods, if we talk about how does it work under the hood, it is actually using the classic for loop construct itself. But for developers, it is making it easier because it knows that if you are iterating over a collection, you will start with the first element and you will go till the last element. So it knows the initialization value, the termination condition, and it also knows the increment condition. And that's the reason you will use enhanced for loops in Java for iterating over collections. Hello guys, let's get started with nested for loops in Java. So in front of you, you can see an example which I have prepared for nested for loops. And in this particular example, I have created a two-dimensional array. As you can see on the line number 6, I have created an integer array and I have put two square brackets here, which are basically symbolizing that this is a two-dimensional array. So this two-dimensional array is going to hold technically a 2D matrix. And we are going to use the concept of nested for loops to print this 2D array in a 2D matrix style where you will be able to see the rows and columns clearly. Let's first try to interpret this particular 2D array. So we have a curly braces outside, and then we have these three inner elements, which symbolizes three rows basically. So this is the first row, this is the second row, and this is the third row. And then each of the rows have three elements each, which symbolizes the column values or the item values. So it's basically a 3 into 3 2D array, which has three rows and three columns. So we can say that this is basically a 3 into 3 array, which has 3 dimensions on the row side and 3 dimensions on the column side, or just a 3 by 3 matrix or 3 by 3 2D array. So as we know that in case of arrays, everything starts from 0. So technically, if we talk about the indexes, it would be the index 0, index 1, and index 2 on the row side. And similarly, index 0, index 1, and index 2 on the column side. So that's something which you should remember, because we are going to use this particular concept when we write the for loop. So let's try to write the for loop now. If you look at line number 8, we put this keyword called for, and then we write the initialization. So we say int I equal to 0. Then we are writing the termination condition, and we are saying run this particular loop, run this whole loop which ends at line 13 till I is less than 3, and keep incrementing I at every step. That's what I'm doing in the line number 8. Then inside the for loop, I'm writing another for loop which has another different variable called j. It can be anything, you can name it anything you want. And this also starts with 0. And this also has a similar condition which says run this particular loop, the line 10 basically, or this loop, which is signified by this curly braces, run this particular loop till the time the value of j is less than 3 and keep incrementing j at every step. And at line number 10, print the element of array which has the current value of I and the current value of j. These are basically the positions. These are not the elements. The element would be represented by this hole, but print the element which is at current I and j's position values. That's what this code means. So let's try to do a dry run on this particular code to understand how this is going to work. So at first we have I equal to 0. 0 is less than 3 and it goes inside. It initializes j as well with 0, and j is 0 is also less than 3. So this condition went true. That's why we went to line number 9, and line number 9 condition also went to true. So we went to line number 10. Remember that in this particular case at line number 10, the values of I and j are 0 and 0 respectively. And we are saying print the array of 0 and 0. So 0th rows, 0th column element should be printed. So this is the 0th row because this is the first subblock, and this is the first element. So in this case, in line number 10, 2 should get printed. Then it goes here and it increments the j to 1. So 0 plus 1 becomes 1. It again checks the condition, is 1 less than 3? So yes, 1 is less than 3. It goes here. Remember, it did not go up at line number 8. It just came back from line number 9. So when it comes here, I is still 0, but j has moved from 0 to 1. So now we are trying to access the element which is at 0th row, first column, which is going to be 7. So 7 is going to get printed. Similarly, on the next iteration, j is going to get incremented from 1 to 2. And again, the condition will be evaluated. So 2 is less than 3. All good. It will again come back to line number 10. And now it will say print the value of 0 row, third or the second column or the third element. So 0th row, third element, which is the 9. So 9 will get printed. Then again j will be incremented and j will become 3. 2 plus 1, 3. And now the condition will be evaluated. Is 3 less than 3? No, it is not less than 3. The condition becomes false. So it breaks out of the loop, goes to line number 12, prints an empty line because we are not writing anything here. So it will just print a blank line. And now it will go back to line number 8's condition and it will do an increment of I. And now I will move from 0 to 1. And now the evaluation will happen. Is 1 less than 3? Yes, 1 is less than 3. So it will again go to line number 9. Again initialize j with a fresh 0. The previous j got destroyed the moment you came out of the loop. So this is a new j. So this j again gets initialized to 0. 0 is less than 3. It goes here. Remember, I was 1 in this time. So now it will print the value of this 2D array, which is sitting at 1, 0. Basically second row, first element. So second row, first element, which is 3. Again, j is going to get incremented and it will become from 0 to 1. So 1 is less than 3. Yes, it will again come here and it will print the value of the array, which is sitting at array of 1, 1 for a row equal to 1 and column equal to 1, which will be 6. Similarly, j will get incremented again. Again, 2 is less than 3. Come back here, we'll print 1. Then again we'll increment j. J will become 3. 3 is less than 3. No, it's false. The condition is false. So it jumps out of the loop, goes to line number 12, prints a blank line, again goes back to 8, line number 8, increments I, and I now becomes 2. 2 is less than 3. Yes, it will again go here, initialize j again with 0, and again does the same thing for the row 2 and column 0, 1, 2. And again, it will come out of the loop. This time, again, when it will go here, the value will become from 2 to 3, and 3 is not less than 3. So then it will break out of the outer loop. So the idea is execute the inner loop for every value of the outer loop. Remember this line because that is how you will be applying your knowledge of nested for loops to be used in certain condition. So whenever you have a scenario where you have to iterate over a collection based on a certain value of another collection, then you can use nested for loops. Or you have a scenario where you have to iterate over 2D or 3D arrays. For example, if we were dealing with 3D arrays, then you would have seen three nested for loops here, and where it will apply the same logic that iterate over all the collections, all the values of the inner loop on a particular value of the outer loop. Then increment the value of the outer loop and do the same thing again. Iterate over all the values of the inner loop based on a fixed value of the outer loop. So let's run this program and let's see what kind of output do we get. So like I said, our motive, our target was to print this in a matrix style. And you can see that it is printing in a sort of a matrix representation. So the first row gets printed here, then the second row gets printed here, and then the third row gets printed here. If you try to decipher it, it will work exactly the same way as I explained. So I equal to 0, 0 less than 3, condition becomes true, comes here. J equal to 0, j less than 3, condition becomes true, comes here, prints the array of 0, 0, which is 2. Then prints the array of 0, 1, which is 7, 0, 2, which is 9. Then j becomes 3, it breaks out of the loop, goes up here, I becomes from 0 to 1, 1 is less than 3, yes, again comes here, reinitializes a fresh for loop with a new j setting to 0, and it will print the array of 1, 0, 1, 1, 1, 2, then similarly array of 2, 0, 2, 1, 2, 2. So that's basically what we are doing. We are picking the first row and iterating all elements of it, picking the second row, iterating all elements over it, and so on and so forth. You can do this for any n-dimensional kind of array or a collection.
So what are objects? An object is an instance of a class. Let's have a look at an example. In this example, animal is a class and dog is its object. The object dog has states and behaviors. We can have dogs with different breeds, sizes, and colors. These are considered as the states of object dog. On behavior side, dog has behavior like barking, eating, and wagging tail. So an object has its own states and behaviors. Now let's look at an example using Java code. There are many platforms to run Java program. So for this video, I'll be using IntelliJ. So let's create a new project. Let's name it as project 1 and finish. There we go. We have a new project. We have a class with main and we have a main function. So the code that we write should always be written in the main function. So let's create a new class to understand how the object is used. Let's name it as student. We need variables so that we can access the variables of this class. So I'm going to use student ID with the integer type, student name, and student's age. There we go. Now we have these three variables that we can use. So let's go to our main program and start our coding. So we have a class named student. Now let's see how to create an object of a class. This is the syntax to create an object. Now the object here is S. I created an object S of class student. Now let's assign values to the variables. For this, we use the object S and use the dot operator, and we have options from which we can choose from that we declared in the class student. So for this, I'll use ID and give a value. Similarly, I'll give age and give a value. And finally, let's give a name. Now we'll print its value. Now we are going to run this program. Let's see what output we'll get. And there it is. We have name, that's Simplilearn, we have age, and we have ID. Now let us see an example how we can use multiple objects for a single class. So let's get started. Let's create a new project and I'm going to name it as vehicles. Because I'm going to use cars and bikes in this program, so I'm going to use vehicles as a combined form. And yes, here we have a class main and a function main. Now I need two classes for this program. So I'm going to create two classes. First, I'm going to name it as bikes, and the second class, I'm going to name it as cars. So let's create variables for these classes. So in cars, first I need string, name, and I need the cost of the car. So cost can be integer as well. Because I'm going to use $sign in that, so I'm going to use string because of that. So same thing I'm going to do with bikes.
Now that our classes are created, let's create objects for this class. So the process is same, but we are going to use different names for the object. First, the car class, and I'm going to name as car1. And yes, we have created the first object. Now to create the second object, similarly, I'm going to create 5 objects of the class cars. And I'm going to change the name for them. So I created 5 objects of the same class. So I'm going to create 5 objects of the bikes class as well. So bike one will be a bit longer, so I'm going to use B1 till B5, and I'm going to name them to from B1 to B5. So now I'm going to assign values to the variables that I created in classes bike and cars. So first I'm going to go with cars, and let's name it as Lamborghini. Similarly, car 2, Ferrari. So I'm going to use names of the cars that are very famous and costly so that anyone over the world can understand this. So let's name car 3. I'm going to name it as Bugatti. Similarly, car 4, Pagani, and car 5. Now I'm going to give names for bikes. I hope everyone will understand the names that I give. B4 and B5, the last one, Yamaha. Now let's assign the cost for bikes and cars as well. So the procedure is same. So let's do at 130,000. Same B2. So B1 goes for Harley Davidson, B2 for Ducati, B3 for Suzuki, B4 for Ecos, and B5 for Yamaha. I am going to assign values for these values accordingly. For Ducati, $232,000. For Suzuki, 200,000. 300,000. And the last one, Yamaha, 500,000. Now similarly, I'm going to assign values for car1.cost till car5.cost. $203,000 for Lambo. I think I can copy paste these as well. So let's copy paste. It will be a lot faster and easier to do. Car 2, car 3, car 4, and car 5. We don't need this. As per car 2, let's take it as 252,000, and let's make it as 3 million. As per this, let's keep it as 1,400,000, and lastly, let's take it as 293. Now that we have assigned all the values for all this, now let's print it and get the value. I'm going to create a very simple program, but a very user-friendly program. So it's going to be interesting for you guys. So we are going to ask the users what would they like, either bikes or cars. So we need to give them the options, and our next program will be based on the options that the users select, not the options we give as the command. So let's do it. Let's give the options 1 bikes and 2 cars. I need to take the value that user gives. For this, I'm going to write this command. So I have not used scanner yet. So let's import scanner. And let's create an object for scanner. And yes, let's get back. So the data type of choice variable is integer. That's why I'm using next int. If the data type was string, then I would have used next line. So now that we have choice from the user, let's use this value. If the user chooses the first value, that means bikes. So the next thing we display is we have models, and we are going to give 5 models for bikes to the user. Here I am giving options to the users so that they can choose easily from number 1 to 5. Now we can show these options to the users so that they can choose from one of these values. So let's use one more if statement so that we can find out whether they have this value or not. Before that, I'm going to ask which one would you like to choose. To enter the choice, I'm going to use one more variable. Let's say n. So I'm going to store n. If n is equal to 1, that means Harley Davidson. Then I'm going to show the cost of Harley Davidson. This is the syntax to print the value for the cost or any of the variable that we use in class. What if the user says second or third or fourth or fifth? So for that we are going to use else if statements. If n is 2, that means Ducati. So we have to show the rate of Ducati or the cost of Ducati to the user. Now similarly, I'm going to do for n is equal to 3, n is equal to 4 and n is equal to 5. Now I'm going to do for n is equal to 4. And lastly, n is equal to 5. That is our last bike, Yamaha. What if the users put a number that is not between 1 to 5? So for that I'm going to use else statement and put a message that please enter the value from 1 and 5. So now we have code for the bikes, and the same thing, what if the user selects that he wants to find the car? So for that we have this, the choice is equal to 1. So the same thing we are going to do for choice is equal to 2. And the same thing we are going to tell to user that we have 5 models. The same names that I gave to variables, I'm going to give this to here. Second one Ferrari, third Bugatti, fourth Ecos, and the last one Porsche. Now we are going to ask the users their choice, that which number do they want to choose. Now we need one more value so that we can have it as a variable which can store the choice of the user. So for this I'm going to use C. Now if C is equal to 1, that means if the user wants to see the cost of Lamborghini, that he puts the choice as 1. So we're going to display this message, the cost of Lamborghini. And we are going to use else if loop to enter the next values for C from 1 to 5. If C is equal to 2, that means the user wants to know the rate of Ferrari. Then we are going to show the cost of the Ferrari. Same thing if the user enters 3 as the choice. If user enters 4 as the choice, then we go for Ecos. And the last one, if user enters the choice as 5, then we have to display the cost of Porsche. Now what if the user enters none of the values from 1 to 5? Then we have to display a message showing that please enter the value between 1 to 5. Now remember the first choice that we wanted from user to enter either bikes or cars. So what if the user do not enter either 1 or 2? So for that we need one more else function to tell the user that either enter 1 or 2. And with this we have completed our code. So now let's run this program. For this we need to go to run and then run main. There's a shortcut for it, that is Shift plus F10. So let's run the program. And yes, we have successfully executed the program. Let's test this program now. So enter your choice. I'm going to enter 1. And yeah, we have 5 models: Harley Davidson, Ducati, Suzuki, Pagani and Yamaha. So enter your choice. I'm going to enter 1. And yeah, we have our result. The cost of Harley Davidson is $130,000. So with this, we have completed our code. And please feel free to type this code in your own computer and try out all the permutation and combinations that you can with this program. So with this, let's move on to classes and understand the classes and their concept. Then we'll have a new program on classes. Now let's see what is a class. A class is a blueprint from which objects are created. A class describes state or behavior of an object. In this example, dog is a class. The variables in this class are breed and color. The functions or methods of the class dog are barking, hungry and sleeping. We use objects of a class to use variables and functions of the class. With this, let's understand classes with a simple Java code. Let's create a new project. Next, tick the box and let's name it as automobiles. Let the base package be student. And yes, we have a class main. Now let's create some classes to do code on. I'll create a new Java class as cars. And then I'll create one more class with the name bikes. And then one more class automobiles. So I'm gonna connect cars and bikes with automobiles so that we can use that program in main and see what can we do with the classes that we create. In automobiles, I need some variables. I'll take private, double and let's say fuel. And then same thing, private, double and then year. And let's take one more, private, string and brand. Now let's have getters and setters for this. So these are used to get the value and set the value for the variables inside the class. There we go. We have the getters and setters for it. Now let's go to class cars. So public class cars extends automobiles. So in it, I'm gonna create one more class or a constructor. And I'm gonna print a message. Say a new car has been created. Car has been created. Now the same thing I'm gonna do with bikes. Let's go to bikes and I'm gonna use the same thing, extends automobiles. This is because I can inherit all the variables from the automobiles class. So I created a constructor and I'm gonna print a message. A new bike has been created. So I have created class, cars, bikes and automobiles. So let's go to main program. So this is where we should write our code. So I'm going to start with the code now. It's a very simple code. First I'm going to create the variables or the objects of the class with private bikes, bike. So one is car and one is bike. Both are objects for the classes. So I'm going to use these objects. Bikes, bike is equal to new bike. This is so that my object can function really well, and now I'm going to run it. It will take some time to run. And yes, there we go. Our program has executed and the things that I typed, a new car has been created, a new bike has been created, are done. Now let's try something else using the classes. So I'm going to bikes. So I'm going to create a new method or a new function, public void kick for bike. So I'm going to print message. The bike has been started with kick. Bike has been started with kick. Now the same thing I'm gonna do with cars. Now how does a car start? With the key. So I'm gonna make a function public key, and inside it I'm gonna print the same message, car has been started with key. Oh, I should write void there to give the return value as void. So let's print the message, car has been started with key rotation. Let's write that as well. So in the main program I'm going to use objects to use those functions, and let's see what changes they'll do to our program. Bike.kick and car.kick. Let's run this. And there we go. First we used to have this two messages, but now these two messages are also there as well, because we invoked those functions and methods that are there in class cars and bikes. So if I write bike.key or car.kick, this won't work. This is because key is not a method of bike or kick is not a method of car. So that's why I gave private static for the functions. So if I execute it, these are the error messages that I'll get. Cannot find the symbol method kick or method key. Let's talk about arrays in Java. An array is a data type that contains homogeneous elements. Homogeneous means all the elements in the array are of the same data type. An array is a group of like-typed variables that are referred to by a common name. On screen, you can see the syntax for array in Java. Now let's have a look at an example. All the components of this array are of the same data type, integer. Each of these elements has an index value associated with it. The index is the position of the elements inside the array. The index of an array always starts with 0. Now let's talk about features of an array. In Java, arrays are dynamically allocated. This means the compiler does not need to know the exact amount of memory required for the program in advance. Next, all elements are stored under one name. This means that the elements of an array are known by their array name. Lastly, array occupies contiguous memory location. An array is stored in adjacent memory locations, unlike linked lists. Now, let's have a look at an example using Java code on how to declare and use arrays. Let's create a new project. Next, tick the box. Let's name it as array program. Our class main is created, and let's write a code for arrays. First, the syntax we use in Java. The data type int, bracket, and name of the array. Let's take ARR. Now we have to give size of the array. The name of the array is equal to new int and the length you want for the array. Let's take it as 5. So now let's give values to the elements of the array. As the array starts with 0, I'm going to assign 0 and then give a value 10. Similarly, for the index 1, I'm going to give value as 20. For index 2, 30. For index 3, 40. And lastly, for index 4, 50. Now let's print the elements of the arrays. For this, I'm going to use for loop. For int I is equal to 0, as the index starts with 0, I less than array of length, and I plus plus. Now let's print the statement using system.out element at index. Let's print the index first. Index is I, and next is and the value of the element ARR of I. Now let's run this program. This might take a while. As you can see, the program has executed successfully, and the result, the value of the index and the value of the element is shown 0 to 10 till 4 to 50. Now what if we put an extra element? Let's try it out. We have 5 elements, and the next element I'm going to put as 5 and give it as 60, and I'm going to run it. Shift F10. So this gives an error. As you can see, the error was out of bounds exception, and it gives 5 because the length of the array was 5. Now that we have seen a basic program of array, let's move on to the types of arrays, and let's look at examples using them. We have three types of arrays. First, we have a one-dimensional array. It is also known as linear array and the elements are stored in a single row. As you can see the example above, the name of the array is array with data type integer. 5 indicates that the array can store 5 elements. The index goes from 0 to 4. Next, we have a two-dimensional array. Two-dimensional array stores the data in rows and columns. If you can see the example, the array has 2 rows and 5 columns. The index starts from 0, 0 in the left upper corner to 1, 4 in the right lower corner. And lastly, multi-dimensional arrays has combination of 2 or more arrays or nested arrays. Now let's have a look at an example of 1 and 2 dimensional arrays using Java code. Let's create a new project. Next. Tick the box, next, and let's name it as dimensional arrays. Now we have a class main, the class main. There are two ways we can assign array. One I have done before. This is the second type you can use to assign values, declare and define array. We use two flower brackets and write the values inside it separated by commas and then semicolon. This is how we declare array in the starting. Now we need a sum so that we can have sum of the arrays, assign it as 0. And then we are going to use for loop to get the sum of all the arrays. For int I is equal to 0, I less than array length and I plus plus. Now we are going to get sum of arrays. Sum plus is equal to array of I. Now let's print the sum of this array, system.out.println, and write something, sum of array is, and print array sum. And let's execute it. And yes, we have our output. This is sum of array is 15. If you add 1, 2, 3, 4, 5, you will get the sum as 15. This 1, 2, 3, 4, 5. Now let's delete everything and try to do two-dimensional arrays. For this we use int array name, let's call it as ARR, and two brackets. Now we use a flower bracket and one more flower bracket for rows. In rows I'll type it as 1, 2, 3. In second row 4, 5, 6. So with each bracket rows are divided and the elements inside the rows are known as columns. Now we use for loop. We are going to use two for loops. First one is int I is equal to 0, I less than 2 because there are only 2 rows, and I plus plus. I need to change the bracket. Yeah. And declare one more for loop. Int j is equal to 0, j is equal to 0, j less than 3 because there are 3 columns, and j plus plus. Yeah. And let's now print the values. System.out array of I and array of j, and give it a space. Now I need one more line to get to the next line after printing one row. So for the next line I'm going to use system.out.println, and I'm going to delete that ln before, and now let's execute it. Here we have our result. 1, 2, 3 are in a row, 4, 5, 6 is the second row. So now let's try it with multi-dimensional. What if I put one more row inside it? 7, 8 and 9. So that means I have to change the value for I less than 3, because now we have 3 rows. And now let's execute it. And yes, we have our result. We have 3 rows now. 1, 2, 3, 4, 5, 6 and 7, 8, 9. I hope you like this demo. Now let's move on to the next topic, sorting and searching for arrays. Now let's talk about searching and sorting using arrays. First, let's understand sorting using an example. We have an array of 7 elements from index 0 to 6. The value of elements are given in random order. Then we use sorting algorithm to sort the array in ascending order. When the algorithm is applied, you can see the result on the screen. All the elements in the array are sorted in ascending order. This is how sorting works. Now let's move on to searching in arrays. In this example, again we have an array of 7 elements. Suppose we have to find the element 11 in this array. We execute a searching algorithm to find the element. You will see the result something like 11 number found at index 5. So this is how searching works in normal array. So now let's see examples of sorting and searching using Java code. So there are many types of searches, but for this program we are going to use binary search algorithm. So let's create a new project. New project. Next, tick the box, next, and let's name it as searching. We have our main program here. Now let's create a new class. Right click, new, Java class, and name it as binary search. We have a new class here. So first I'm going to create a constructor, int binary search. Now what is binary search really? Binary search compares the target value to the middle element of the array. If they are not equal, the half in which the target cannot lie is eliminated, and the search continues on the remaining half. Again taking the middle element to compare the target value and repeating this until the target value is found. So for this I need int array, int left L, int right value R, and the element I want to find int X. So sometimes there are only one element in the array. So to make sure there are two or more than two elements in the array, we are going to use the right element is greater than 1. If right R is greater than equal to 1, then the code starts. We need a mid value to get the middle element. Int mid is equal to, we have to calculate it, left plus right minus 1 divided by 2. One more bracket there. And what if the middle element is the element we are trying to search for? Then if ARR of mid is equal to X, then I'm gonna return mid. This means I'm gonna return the value of the mid. Now what if the element we are searching for is not the middle element? Then if ARR of mid, yes, is greater than X, then I'm gonna return the same program, the same constructor, binary search of ARR left, and now the right becomes mid minus 1, and the element I want to find X. If ARR of mid is less than X, for that I'm going to write this sentence, return binary search of array. Now in this case left becomes mid plus 1, right remains same R, and the element X. Now I need to return a value for this constructor. Because the data type of this instructor is int, I need to return some integer value. For this, return minus 1. I think I need to delete one bracket, this bracket. Yeah, now this class looks fine. Let's move on to main class. In main class, first I need to take the scanner. So I'm going to import java.util.scanner. So I'm going to write the code starting with, I'm going to create an object for scanner so that I can scan all the elements that the user inputs. Scanner s is equal to new scanner system.in. And next I'm going to create an object for the class binary search. So binary search ob is equal to new binary search. And yes, I'm going to declare one array now, int ARR is equal to new int. Let's take the length of array as 5. Now I'm going to print a message for the users so that they can put the input system.out, and the message, let's type enter the elements of the array in ascending order. Ascending order is essential for this algorithm so that we can search easily, and this search is properly based on this. Now to get the elements I'm going to use for loop for int I is equal to 0, I less than array.length, and I plus plus. Now to take the element, ARR of I is equal to s dot next int. Now that we have taken the value from the user, now let's ask the user which element they want to find. For this I'm going to print the sentence system.out, enter the elements you want to search for. Now I'm going to declare one more variable, num is equal to next int, one more variable to get the length of the array, int n is equal to ARR dot length. Now one more variable so that we can store the result of the class. Int result is equal to ob object of the class binary search dot binary search, and the elements as ARR, left would be 0, right will be n minus 1, length of the array minus 1, and the element we want to find, num. Now if the result of the array is equal to minus 1, the result that we passed in our class binary search is equal to minus 1, then I'm gonna print element not present. And if the result is not minus 1, then I'm gonna print the value of the element as out element plus the number of the element name num plus and the index of it, and the index will be stored in the result. Now let's run this program, and we have successfully executed it. There are no errors in the program. I'm gonna put the elements now. I have put 5 elements 1 to 5 and to search for 3, and yes, I can see the result, element 3 found at index 2. And that's true, index starts from 0, so the element would be found at index 2. So this was it for the binary search algorithm. You can try this method or you can try with different elements, anything you want to do with this program. And now let's move on to the next program for our searching algorithms. There are many sorting algorithms, but for this program we are going to use bubble sort. So let's get started. Let's create a new project. Tick the box. Next, let's name it as bubble sort. We have our class main. Now let's create one more class, and I'll name it as bubble sort. A bubble sort is an internal exchange sort. Instead of searching an array as a whole, the bubble sort works by comparing adjacent pairs of objects in the array. If the objects are not in the correct order, they are swapped so that the largest of the two moves up. So this is how bubble sort works. Let's try to do coding on this. I'll create a new class, or mainly a constructor, with void bubble sort, and parameters I'm going to give as int array. Now I'm going to use n as getting length of the array. For this I'm going to require two for loops, nested loops, one for I and one for j. So for this, for I, I'm going to go int I is equal to 0, I less than n minus 1, and I plus plus. I'm going to use one more loop j is equal to 0, j less than n minus I minus 1, and j plus plus. I have to assign int data type, and yes. And next I'm going to use if loop. If array of j, arr of j is greater than arr of j plus 1, that means we are comparing two adjacent sides, then I'm going to assign one temporary variable, and the temporary variable will contain arr of j. Next I'm going to swap j to j plus 1. Array of j is equal to array of j plus 1. And lastly, array of j plus 1 will contain the value that is there in temp. Arr of j plus 1 is equal to temp. So this will be the code for our bubble sort algorithm. And next I'm going to create one more function to print the array. I'm creating this function to print the sorted array. The same thing, I'm going to assign n to array of length, and then I'm going to type the message sorted array. And next one more for loop to print all the elements of the array. For int I is equal to 0, I less than n, I plus plus. Now system.out for printing the array, arr of I and one space, and next system.out.println for the new line. So this created our bubble sort class. Now let's move on to main class. First I'm gonna import the scanner to get the value from the user. So import java.util.scanner, and now we move on to the new code. First the object of the scanner, new scanner system.in, and now I'm going to create an object for bubble sort. Ob is equal to new bubble sort So OB is the new object created for bubble sort class. Now I'm gonna assign array and new integer. For now let's take it as 5, and now message to enter the elements. Enter the elements. Now I'm gonna use one more for loop. This is to get the values of the array. The same loop I less than array dot length I plus plus arr of I is equal to s dot next int. Now I'm gonna run the program. The class that we used in bubble sort, ob dot bubble sort of arr. And now to print the message. This message is to print that all the elements are sorted in the array. This is mostly used to make it as user friendly. So I'm for printing array, one more function. And now let's run the program. And yes, we have executed successfully this program. I'm gonna enter the elements 1, 5, 9, 2, 4. And yes, we have the sorted array. All the elements before were not in order, and now all the elements are in ascending order. Similarly, we can do with descending order also if we put I as the maximum and then reduce I and j by using I minus minus or j minus minus.
So, are you ready to take your career to new heights? The demand for full stack web developers is soaring in today's fast paced world. And now, Simplilearn presents the perfect opportunity for you to excel in this exciting field with our postgraduate program in full stack web development. This comprehensive program will equip you with the foundation to build full stack web applications using the power of Java programming language. From the basics of JavaScript to advanced level concepts like Angular, Spring Boot, Hibernate, JSPs, and MVC, we have got you covered. What else can you expect from this program? This program includes Caltech CTME postgraduate certificate, enrollment in Simplilearn's Job Assist, receive up to 25 CEUs from Caltech CTME. Simplilearn's Job Assist help you get noticed by the top hiring companies. You'll also get to attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by CTME program director, 20 lesson and 5 phase end project.
Let's see what strings are and how we can use strings in Java. Java strings are objects that contains groups of characters. Like arrays, strings are immutable as well. Immutable means once string is created, they cannot be changed or manipulated. If we use a string hello, they are stored in a memory location like this. 0, 1, 2, 3, 4 are the addresses of the locations where each character of the string is stored. Now let's move on to creating strings. There are two methods of creating string literal method and using new operator. This is the syntax of string on the screen. First, string type, then variable name is equal to sequence of characters in double quotes. This is called as string literal method. For new operator method, we use new operator and value of string is given in the brackets. Now, let's see a simple program to understand the use of strings with Java code. Let's create a new project. File, new, project, next, tick the box, next. I'm gonna name it as strings, and for the base package I'm gonna name it as string as well, because all the programs I'm gonna do in this package for strings. We have our main program right here, the main class. Now before importing the strings, we need to import some pre-processive directives. So for this I'm gonna import java.io input output dot star. Star means everything inside the directive. And I'm gonna import java.lang dot star. This means I can do all the operations that is needed for strings. So there are two ways to declare string. This is the first one. String s is equal to Simplilearn. Now we have a string s and it contains the value Simplilearn. Now I'm gonna print this system.out.println plus s, or I'm gonna name it as string. I'll print string first is equal to, and then I'm gonna print this. So double quotes string is equal to and plus s. So let's run this program, and there we go. we have string is equal to Simplilearn. So it took the value of s and printed that. So let's see the next type of string, how we can declare the string. Str is equal to new string Simplilearn. So this is the second method how we can declare a string or assign the values to string. So to print it, I'm going to use string2 is equal to and then plus str. So let's execute this as well. And as you can see, we have string2 is equal to Simplilearn as well. So this means both the methods are to declare strings or to assign values to the strings. So you can use any of them. I prefer using first, so it's easy. That's why you don't need to write new and string. So let's move on to the new topic, classes and strings. We all know that strings are immutable. Now what if we want to change something inside the string? Then we use these methods to manipulate strings in Java. First one is string builder. The string builder in Java represents a mutable sequence of characters. It is an alternative to string class as it creates a mutable sequence of characters. Next is string buffer. String represents fixed length immutable characters of sequences, while string buffer represents growable and writable character sequences. It will automatically grow to make room for additions like appending, inserting, and deleting. Next, we have string tokenizer. A string tokenizer object internally maintains a current position within the string to be tokenized. Some operations advance this current position past the characters processed. String tokenizer class in Java is used to break a string into tokens. A token is returned by taking a substring of the string that was used to create the string tokenizer object. Now, let's see different methods for functions that can be done on strings in Java. We have lot of methods or functions in strings. These are few of the methods that are used by programmers frequently and we will be using in this series of our Java tutorial. First one, we have int length that returns length of the string. Second, we have string substring int begin index that returns the substring for given begin index. Next, we have boolean is empty that checks if the string is empty or not. Next, we have string concat string str that concatenates the specified string. Next, we have string split string regex returns a split string matching regex. Next, we have int index of int ch that returns a split string matching regex. Next, we have string to lowercase and string to uppercase. These are mostly used when we want to convert a string into a uppercase or into a lowercase. Next, we have string trim that removes beginning and ending spaces of the string. If we have any beginning or end spaces that may not be required for our string, then we use this. Next, we have static string value of int value. This method converts given type of into string. It is an overloaded method. And lastly, we have string replace character old and character new. It replaces all the occurrences of the specified character value. Next, let's have a look at a program where we are going to reverse a string and compare to a string. This is going to be an interesting program and you will be able to understand string a lot better. So let's get started. So first we'll see how to compare two strings and then we'll see how to reverse a string. So let's create a new project. File, new project. Let's click on next, tick the box, next. I'm going to rename it as compare and reverse because I'm going to do both the programs in the same program. And we have our main function here. To use some classes or to use some methods, we need to import some of the strings from Java. So I'm going to import strings dot compare dot string compare. So let's write our code here. So I'm going to use 4 strings. First string s1 is equal to, then I'm going to use new string and inside it I'm going to name the string as Simplilearn, S capital. And for the next string, string s2 is equal to new string. Let's give it as practice. For the third string, s3 new string, let's give it as study. And for the fourth string, we are going to match the third string to show all the outputs that's possible. Study. Now we are going to display some output using the function equals. So what equals does is it compare two strings. So first I'm going to make it as user friendly by writing comparing string 1 and then comparing string 2 and then semicolon, so that everything will be separated. You can easily find out what the result will be. And then this is the main part, s1 dot equals, and in the bracket s2, because we are comparing s1 and s2, so s1 dot equals s2. So this function automatically checks whether s1 is equal to s2. Now same thing we are going to do with string s3 and string s4. Again this user friendly, s3 and s4 semicolon s3 dot equals s4. We know that s1 is not equal to s2, but s3 is definitely equal to s4. So let's try it with one more sentence so that we can compare one more string. So I'm gonna compare s1 and s4. So I'll copy paste it, and instead of s3 I'll write s1, and same I'll do with s1 dot equals s4. So let's run this program. Oh, before running we have an error here, so I'm going to delete that import because we have not used it. So now let's run the program, and yes, we have a result. Comparing Simplilearn and practice is false. That's definitely false. Study and study, both strings are matching, so it's true. And Simplilearn and study, they don't match, that's why it's false. So let's get started with our second program, that's reversing a string. So I'm going to delete everything from here, and I'm going to write same code here only. So first I need to assign a variable of string input equals, I'll name it as Simplilearn, and this is the main part guys. We use string builder because the string is immutable, as we discussed earlier. String builder allows us to do manipulation. So I'll use one more variable input1 and new string builder. So in input1 we can do any manipulation that we require. So first I'm gonna do input1 dot append, so that I can do operations that I want on it, either reversing or deleting or concat. So I'll take append of input, and lastly input1 is equal to input1 dot reverse. This function reverses the string that is there in input1. Now to print the value of the reverse string is, and then input1. So here's the catch guys, we have to use string builder so that we can do manipulations inside the string. If we don't use string builder, then we will get an error that unable to manipulate the string or unable to reverse the string. So string builder is the main thing here, so that we can do all the operations that we want, either reversing or concat or deleting anything from the string, or deleting an element or adding anything to the string. So all that happens because of string builder. So now let's run this program, and there we go, we have a result. The reverse string is the reverse of Simplilearn. Now let's try it with something that is palindrome. So we have our language Malayalam. If we reverse this, we'll get Malayalam. So this is kind of palindrome string, and see the result. Our reverse string is also Malayalam. So this is how you reverse a string. So this brings us to the end of this video. We learnt about strings, the functions for strings, and the methods we use in strings. And lastly, we learned how to compare two strings and how to reverse two strings.
What is an abstract class? The answer is, abstraction is one of the keys to achieving an object-oriented programming approach in designing a software. Here, the programmer tries to hide the complicated implementation of the code, which makes the software run smoothly. Most of the time, the user isn't interested to know how the code is being implemented. So, through abstraction, we can just hide it. To do so, we use an abstract class or sometimes an interface based on the requirement. So, abstract class in Java is considered as a template of methods and variables which are used in a program. Remember, abstract classes cannot be instantiated directly. Now moving ahead, we will next learn the important features of abstract classes. So the first one is template. The main reason programmers prefer to use abstract methods is because they act as a predefined template for any future specific class that you might use. Next, Loose coupling is a procedure where an internal object gets the necessary method or a different object from the external world, that is, other than the current working project. The use of abstract classes makes this process possible. After that, we have the code reusability. Implementation of the abstract classes provides the developers with one of the greatest features that saves time, which is none other than the code reusability. Followed by code reusability, we have abstraction. As discussed earlier, data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract classes or interfaces. Last but not the least, dynamic method resolution. The abstract classes enable us with dynamic method resolution or the dynamic method dispatch process. The dynamic method resolution is a mechanism by which a call to an overridden method is resolved at runtime. This is how Java implements runtime polymorphism. When an overridden method is called by reference, Java determines which version of that method to execute based on the type of object it refers to. Now, these were the few important features of abstract classes. Next in the docket is the crucial rules to be followed to use abstract classes. Alright, let us go through the rules one by one as mentioned below. The first one is the keyword abstract is mandatory to declare an abstract class. Followed by that, the next rule says that abstract classes cannot be instantiated directly. The third one is an abstract class must have at least one abstract method. Next to that, we have another rule which says an abstract class includes final methods. Next, an abstract class may also include non-abstract methods. It's not mandatory that an abstract class should only include abstract methods. So the last rule says that an abstract class can include constructors and static methods. So these were some crucial rules to be followed to use abstract classes in Java. So far, we have discussed the definition of abstract classes, its features, and the rules to use abstract classes in Java. Now, we will learn how to achieve abstraction in Java. So basically, there are two different ways to achieve abstraction in Java. The first way is by using abstract classes, and the next one is by using an interface. Now, this brings us to our next topic, that is the syntax to be followed to use an abstract class and an abstract method. To declare an abstract class, we use the keyword called abstract. Followed by that, we use the keyword called class. Then after that, we declare the name of our class. The name of the class is up to the user's choice. For example, I have named my class as Simplilearn as shown here. Followed by the abstract class, we have the abstract method. To declare an abstract method, we use the keyword called abstract. Then, the return type of the method. As of now, I have used void. Then, later we have the name of the method that is based on the user's choice. As you can see, I have used Simplilearn as the name of the method. So, this was by using abstract class method. The next one is by using an interface method. Now, what exactly is an interface? So, interface can be defined as a boundary between the method and the class implementing it. In Java, we use interface to achieve abstraction. In other words, we can also consider interface as a container which saves the signatures of the methods used in a program. Now we will move ahead and understand the syntax to use an interface to achieve abstraction in Java. To declare an interface, we use the keyword called interface. Followed by that, we declare the name of a class. The class name is up to the user's choice. For example, I have named my class as Simplilearn as shown below. As discussed earlier, interface acts just as a container that stores only the signatures of the method. We cannot have a complete method defined inside it. All we can do is just declare an interface. Now that we have a detailed explanation about the abstract class and the interface, let us look into some example programs based on abstract classes. Now we have successfully booted the Eclipse IDE. Now let's create a new project. So to create a new project, just click on Create a Project. And this should give you a dialog box wherein you have to select Java Project. Click Next. Now let us give a name to our project. So Simplilearn will be the name of my project here. Now let me click on Finish to finish this process. As you can see, the project has been successfully created. And inside the project Simplilearn, we have the source file, and right-clicking the source file will give us a drop box where you can just select New, and inside New you can select a new package. Now let's name the package as Abstraction and click on Finish to create the package. Moving further, let's right-click on the package and select New, and from New select a class to create a new class. So the name of my class will be Employee. Let's click on Finish to create the class. Now we have our Employee class ready. Now let's right-click on the package and select New, and inside that let us select another class. And the name of this particular class will be Person, which will act as our abstract class. So as you can see, we have declared this particular class with the keyword abstract, and the name of the class is Person. So our first example, which is based on employees, where we will have an abstract class called Person, and this Person class will be inherited by the employee class and gets executed to generate employee details. Now let us try to execute this program and see the output. To execute the program, just right-click on the package and go to the Run option and select the first one, that is Java Application. Now you can see we have the employee named Pavitra and the gender is female, and the employee has logged in successfully. So these are the details which we were expecting to be presented on the output console. Now moving ahead, we shall execute our next example, which will be based on students. So here the class student is the abstract class, and three different student classes, namely Raju, Pranita and Punit, will inherit the student class and generate the output that displays their particular ranks. So you can see our abstract class, that is student, is being declared using the keyword abstract, and inside that we have an abstract method which is getRank. And these classes, that are Raju, Pranita and Punit, will inherit the abstract class student and display their ranks. Now let us try to execute this program and see the output. As you can see, the three classes have successfully inherited the abstract class and displayed their ranks on the output console. Now let us move ahead and try to execute one last example based on abstract classes. So the third and last example is based on interest rates provided by different banks. Here we have an abstract class named Loan, and all the banks described in the program will inherit the loan abstract class to calculate the rate of interest on the loans provided by them. As you can see, we have the abstract class, that is loan, and inside that we have the abstract method, which is interest. So we have the classes Andhra Bank, Bank of Baroda, IDBC Bank, State Bank of India, which are inheriting the abstract class called loan and the method interest to display their rates of interest. Now let us try to execute this program and see the output. As you can see, the program got successfully executed and the rate of interest for loans from different banks is been displayed in the output console. So with this, we have entered into our next topic, where we understand the differences between an abstract class and an interface. So the first difference between the both is the keyword. While we declare an interface, we use the keyword called interface. On the other hand, when we declare an abstract class, we use the keyword abstract. Followed by that, the second difference is, when you use an interface, the subclasses basically implement an interface. While on the other hand, when you use abstract classes, the subclasses extend an abstract class and inherit the properties of the abstract class. Followed by that, the third difference is, multiple interfaces can be implemented, but on the other hand, only one abstract class can be extended at one particular instance. And the final difference between the both is, interface is capable to support multiple inheritance, whereas on the other hand, abstract classes are not capable to support multiple inheritances. Multiple inheritance is none other than the diamond problem, which is not supported in Java. Now that we have understood the differences between the both, let us understand the major advantages and disadvantages of using an abstract class. Now first, we will discuss the advantages. So the advantages of using an abstract class in Java are, the abstract classes are highly beneficial in writing shorter codes. The abstract classes avoid code duplication. They enable code reusability, which is a major advantage. And finally, the last advantage is, changes to the internal code implementation can be done without affecting the classes. So these were few of the major advantages of using an abstract class. Now moving ahead, we shall discuss the disadvantages of using abstract classes. Few of the disadvantages of using an abstract class in Java are, abstraction is expensive as sometimes you need to handle cases and situations which are not necessary. Followed by that, the second disadvantage is, object relational impedance mismatch in the case of RDBMS, and the last disadvantage is, object relational mapping in case of frameworks like Hibernate. So these are the few important disadvantages of using abstract classes in Java that you need to consider before using them into your project.
Let's see the definition of encapsulation. Encapsulation is like a capsule. The whole code and data is bounded together into a single unit. Another way to think about encapsulation is, it is a protective shield that prevents the data from being accessed by the code outside this shield. As you can see, variables and methods are defined inside one class like a capsule. Now the question is, why do we need encapsulation? The main reasons are, first, better control of class attributes and methods. Second, class attributes can be made read-only or write-only. Third, it makes Java code very flexible. This means the programmer can change one part of the code without affecting other parts. Apart from these, encapsulation is mainly used to protect data and increase security of the code. As you can see, to protect the data, variables must be private and they can only be accessed through methods. Now, let's see Java code for encapsulation to understand the concept better. So now let's create a new project. Next. Next. And I'm gonna name it as encap1. So here we have our main class. We can write the code here. So before writing the code, let me create a new class. Right click, new Java class, and I'm gonna name it as employee. So in this program, we are going to use a classic example of employee using employee name, ID, and salary. So in this class, let me create variables. First string name, then integer ID, and then int salary. So I can easily use these variables in our main program by creating object of the class. So let me just create the object. Employee is equal to new employee. Now I can use e.id, name or salary, anything I need to. But this program is about encapsulation. So this is an easy program we can do, but in order to secure our programs when we have a large number of program and large number of lines in a program, so we need encapsulation at that time so that data can be secured. So for that I'm gonna name it as private. Now all three variables are private, so I can't use them. See, we can't see them anymore. If I write ID, we'll get a red color here. So if we go on it, we can see ID has private access. So that means we can't use it directly. Because of this, we need getters and setters that are normally methods that are used for these. So right click, generate, and here you can see getters and setters. So just select all of them and OK. So now we can use these methods instead of direct using the variables. So we can get in the starting, then set, then get, and again set. So likewise it goes like this. So now we have set here. So if I want to declare variable and if I want to put some value inside my variable, so how can I do that? Here you can see get ID or get salary. So if I go for get ID, if I go for e.set ID and I set it as 6, so this shows no error. This means we can use methods to access variables. So let's complete our program now. First I'm gonna set everything. And lastly e.set salary. Let's get it as 30,000. Maybe in dollars or maybe in rupees. Let's just set it as 30,000 for now. So how I'm gonna print it? For this I'm gonna go to a print statement and then name and not set name, but this time I'm gonna go with get name. Get name is to return the value of the name that I have given. So in this case that's Simplilearn. And next will be ID and e.get ID. And lastly salary e.get salary. So this is a simple program that is used to define encapsulation. If we don't use private variables, that becomes a normal program. So when we use encapsulation, we are going to use private every time whenever we declare variables so that it's secure and no one can access the variables directly. So now let's run the program. And there we go. We have our result. We have executed the program successfully. And as you can see, name Simplilearn, ID 6 and salary is 30,000. So I hope you understood the concept of encapsulation. So the main concept of encapsulation is all the variables can be accessed through methods. So for this we use getters and setters that are inbuilt functions for IntelliJ or NetBeans or Eclipse. So with this, let's move on to our next program to understand it better and how we can manipulate these variables or methods using program. So again, let's create a new project. And this time I'm gonna name it as encapsulation 2 because it's the second program for encapsulation. And here we have our main program. Now this time I'm gonna use an example of cars. So let me just create a new class and I'm gonna name it as cars. So in this again I'm gonna create three variables that are private. So first I'm gonna get string name, then private string price, that means price of the car, and third one top speed of the car. So we can create the program that we did before as it is, but I'm gonna explain you more in depth how we can manipulate these variables or classes. So I'm gonna create a constructor for the class cars, and inside I'm gonna give it as arguments as string name, then string price and string top speed. And I'm gonna give it as this dot name is equal to name. This is so that the class can identify that we are going to give arguments related to that, and the class can return the values of it. So similarly, I'm gonna give it as this dot price is equal to price, and lastly this top speed is equal to top speed. So with this we have completed our constructor for it. Now let's have getters and setters for the same thing for these three variables. So generate getter and setter, select all, and OK. This is a great feature that we have in Java, getters and setters. Otherwise we'll have to type the whole code. So with this, let's move on to our main program. We'll write the code here. First I'll create object of the class cars, and inside this I'm gonna give arguments, or inside this I'm gonna give values that I use in constructor to assign the values without using any c.getName or c.getPrice. So my first was name, so let me just name it as BMW. The second thing was price, so I'm gonna give it as $30,000. And the third one was top speed, so top speed I'm gonna give it as 200 km/h. So we have assigned all the values to the variables, and we have created object as well, all in the same line. So this is another way of creating objects, or another way of assigning values to the variables that are private. So if I try to print these, they can be easily printed. So in the starting, name and c dot, so this time I'm gonna give get name, so it automatically gets the value that I assigned to the variables through getters and setters. After that, price c dot price get price, and in the end top speed c dot get top speed. So if I print this, let's execute it, and there we go, we have name BMW, price, and even the top speed. Now if I give spaces between them, it will look neatly. So let me execute it once more, and here you go, name BMW, price $30,000, and top speed 200 km/h. So this is one of our ways how we can declare variables or assign values to the variables without using any getters or setters. So in this method we used only getters to print the value that we have for variables. Now how can we manipulate the variables if we want to change value of them? Now for this, again I can do set top speed or set price. Let the name be as it is. So c dot set price. So price I'm gonna set it as $50,000, and c dot set top speed, let me increase it to 250 km/h. So before printing that, so that we can differentiate which one is new and which one is old, I'm gonna print one more line, stats after updation. So now if I print these values, I'm just gonna copy paste it. So now if I print it, let's execute it. And here you go. First we have name, price, and top speed, then stats after updations. That means after we set the value gets overwritten on the variables, and now we have a new price and top speed and all the details. So this is how you can manipulate variables or values inside the variables.
What is inheritance? There are two other key terms which are not going to be in this agenda, but you should also, when you get to them, make sure you bundle them together as you're understanding these structures. And that's the abstract class and the polymorphism. So what is inheritance? Inheritance is an act through which a new class gets created by acquiring the variables and methods defined in the previous parent class. So when we look at what is inheritance, we can take an example of, say, food. We have veggies, noodles, fruits, where food is the parent
And your veggies, your noodles, and fruits are all subclasses of that. They're all kind of children of food. Why do we need inheritance? We implement inheritance for a multiple of reasons, like creating a possibility to add or remove features, to reduce the code length as we reuse the code, more comfortable to develop and maintain the project. And so if we start looking at, let's say we have a cell phone. We make calls, we have our SMS texting, our communication. On our phone we have our media. We also add a browser on there because now we have a smartphone. And we look at that, we have our phone set up, and then we have our full smartphone, media, call, SMS, and browser. And we start to kind of link these. Instead of making them separate, we can have the call and the text, and then we can have them inherit. We can actually create a media that inherits their qualities. So now you can text your media. Now you can use the browser as part of your call scenario. And I would even add one more example in here, and that is that all programming languages that are object-based are built on inheritance. Java, Python, C++. So this concept of building an object, and then that object then is inherited by everything underneath of it, is important to understand, even in these even as we're looking at more specific cases. So we'll take a look at the components of inheritance. And the most important two components in inheritance, the two major components that are mentioned, are parent class, or the superclass, and the child class, or the subclass. And to see this, let's go ahead and jump into Eclipse and take a look at what the actual code looks like. So the first thing I want to do is go ahead and add in a new package. And we're going to go ahead and call this package inheritance, because that's what we're working with. Oops. Give me a default Java tutorial in there. Inheritance, finish. And I started off with the Java tutorial as just a, went in and created a new project and made sure it was Java based. So we have our package inheritance right here. We're going to go ahead and add in a new class. And we'll go ahead and call this class machine. Now, one of the standards when you're creating classes is to capitalize the first letter, so always remember to do that. In some places, people like to have the whole word capitalized. It really depends on who you're working with. But it is kind of, if it starts with a capital letter, it's probably a class. And so once we have our inheritance, we have our public class machine. Let's go ahead and give it a little bit underneath there to do something. And we'll start with protected string brand. And so whatever machine we're working with, these particular machines are going to be, we'll call them, it'll be a Samsung. Free, they get some free marketing right there for Samsung. So Samsung machines. And then we want it to do something, so let's go ahead and put a procedure in there. And we'll make it public, void, because it's not going to return anything. And we'll call this wash. I guess they're all wash machines. There we go. There's our brackets. A little trouble finding the bracket on there. And let's just have it, during this, we'll just have it do a quick print line. And we'll say initiating cycle. There. And then, of course, our semicolon on the end. All right, so now we have a public class machine. And we're going to get into where we start working with the actual inheritance. You can create an object with this machine. We haven't done anything special to it. It's like any other class you might create in the Java language. And we've added in public void wash, a procedure with no return. That's what the void means. And it's going to print out. And so let's go ahead and create another class in here. New class. And this one's going to be washing machine. Washing machine. And we'll go ahead and hit finish on here. And we come into our washing machine. It's opened up a nice new tab for us. And we might have a private string model name. And we'll change this to model type. Model type equals So the type of machine is a top load washing machine. So we have a Samsung as the main type of machines we're looking at, and we have top loader or top loading washing machine. And then we're going to add up here extends machine. And so this is the key code we're going to look for, because we want this to have the properties of the machine. So this comes in and says whatever's in machine, we now also have in our washing machine. And then, of course, if we're going to do all this, we need to actually be able to run it. And if we're going to do that, we want to go ahead and add in the public static void main, reserved keywords there. And this is just your standard main startup. You have your string of arguments. There we go. And, of course, our bracket. And then in here, we're going to take and create a washing machine object. And so here's our wash machine. That's, of course, the type washing machine. And it's going to equal a new washing machine. So we're initiating a new object in here. There we go. And then we want to do something. And if we're going to have it do something, we want it to go ahead. Let's see what happens when we have wash. Remember, our keyword up there was washing machine dot wash. And where did that come from? Well, if we go back into machine, here it is, public void wash. There's the procedure, and it's coming into the washing machine, and this is inherited. That way we don't have to retype that every time we have a washing machine. This can be washing machine. Maybe the next one is, I don't know, a different kind of washing machines. I'm not an expert on washing machines. But we have it do a wash, and then specific to the washing machine in here, we also had the type. And so we can come back up here, or brand. So we can come up down here, we can go system dot println wash machine dot brand plus put a little dash in there, plus, and then we're going to go ahead and we have our wash machine dot model type. That model type we put in there. So the brand, where does the brand come from? The brand's coming from our machine. We have our protected string, which is going to be Samsung. And then we have our washing machine, which has the model type, which is a top load machine. And if we go ahead and run this, after, of course, we make sure we have that semicolon in on the end there, we come up there, we'll see initiating cycle. Initiating cycle is printed out from machine, and then the Samsung top load washing machine is the second printout line here. And so when we have our wash printout here also, the wash machine wash is initiating cycle, and then we have, that's where that printout comes from. We can go back up here to machine. You can see right here initiating cycle. And then we flip back over to the washing machine, and we print out washmachine.brand, which is the machine class, and then washmachine.modelType, which is underneath the washing machine. So let's go over all that. Let's take a look and see what we're talking about here. So we saw in the code the extends keyword. The term extends is a predefined keyword in Java that allows you to create a new child class by deriving the variables and methods from the parent class to reduce code length and improve the performance. And we see that right up here in our public class washing machine extends machine. So the next key thing to talk about is access modifiers. And I kind of breezed over them when I put together the code, but we'll dig in there a little deeper. When we talk about access modifiers, there's 4 different words you really need to know, and that's default, public, protected, and private. And I'm going to tell you right now, default equals public. So what is default? Default access modifier is set implicitly whenever you declare a class without a specific access modifier. By default, the access of a class or method, when declared without a specific access modifier, becomes available to any other method or class within the same package. And in Java, the default is public. So public, a certain class can be declared as public by using the keyword public. Any class or method, when declared as public, becomes available to any class or method declared in the same package. But if a different method or class needs it, it should be imported. And then we have protected. A certain class is declared protected by using the keyword protected. This provides access to the methods and variables of the protected class only to the rightful subclasses and protects the data from any other classes which are not related. And then private. A certain class is declared protected by using the keyword private. This provides the ultimate protection to the data members and the methods of the private class. This procedure is implemented by class to encapsulate the method and members. So we'll take a little, we're actually going to do a different example in here, but I do like this underneath the washing machine. You can see right here we have put in private, a private string. What this means is that only washing machine can access that private string. Where if you have protected, the children can access it. So a protected screen, if you're underneath a machine up here, we have protected, so that when I create the washing machine and extend machine, I can still access it. But if I create a subclass of washing machine and I mark it as private, that subclass is not going to be able to access it. And so it has to do with what layers of accessing. Think of this as a big team project. You create something, do you really want that to cascade down to the next class? Or who do you want to have access to that? Let's go a little deeper to really bring this home, because it's really important to understand this terminology. Let's go ahead and start a new class here, and we're just going to call this particular class summation. And go ahead and create that, finish. And so our summation class, it's going to be pretty simple in here. We'll go ahead and do public. So anybody can access it. Just remember, here's our public on there. And then we'll just do a integer, because that's what it's going to return as an integer. We're going to call it add, and we're going to put integer x comma integer y. And then we'll just return x plus y. So real simple. We're just adding two numbers. Here's our two inputs. They both have to be integers. And we're going to return an integer, and it'll be the summation of the two. So real simple class right there. And if we're going to have a summation, then let's go ahead and create a new class, and we'll call this one child. And in our new child class, we're going to go ahead and keep this simple, and we're just going to have our public static main. We're going to have our summation a equals new summation, and then system out print line a dot add 100 plus 200. Pretty straightforward. Everything's public in here. Oops, okay. There's our running, and we see the answer is 300. So this is public. If you remember correctly, we're talking about public. And so when we use the public keyword, any class or method when declared as public becomes available to any class or method declared in the same package. But if a different method or class needs it, it should be imported. So here we go. That's our public setup. It's just open to everybody. Well, everybody that's under the package inheritance. So it's whoever's using that package can now use this particular child. And let's go ahead and add a new class in. And this time we're going to do a parent class. I'll just put that right in there. And we come in with our parent class. You can see right here the parent class itself is public. But what we want to do underneath the parent class is we want to create a protected void, because we're not returning anything, and print. So we're going to do the print there. And this protected print, let's go and put our brackets in there. And we'll do just a simple print line hello world. And once we have the print hello world, we want to go ahead and add a child class to this. And let's see, we had the child class when I took it out a second ago. So we'll go ahead and put that back in. Here's our child class. And for this child class, we want it to go ahead and extend the parent. So inheritance, there's our extend on there. Oops, let me retype that. All right, extends parent. So now the child class is part of the parent class. And we'll go ahead and put our main in there so that it will run it and execute it. And we'll create our child x equals new child class. So we'll go ahead and assign our variable x and initiate it. And then we'll do just the print and see what happens here. So here's our print statement. And we'll go ahead and run this and compile our child on there. And when it comes in there, you see it says print hello world. And so the parent has marked this as protected. So it's protected from objects that are not inheriting it, but the child can still access that information and print it on there. So here's protected. This provides access to methods and variables of the protected class only to the rightful subclasses and protects the data from any other classes which are not related. In a lot of programming, that's usually where you end up, is doing a lot of stuff that is underneath your parent that is protected. You either make them public or protected. A lot of people are sloppy and just make them public, but most of the stuff you want to make sure it's protected. And then we finally have our private, and I'm going to go back here to our child, and we're going to run this. And it's going to come up and say proceed with launch, errors in setup, and then it's going to give us an exception thread main. Compilation error, the method print from the type parent is not visible. And that's because unless you actually initiate the parent, you're not going to see this code because it's private. It's only private to the public, to the parent class. So even if I extend it in child, it will not be available. And that again protects it. That means it's something that you don't want to inherit and cascade down because maybe it is a piece of code that is going to be changed. And so you don't want all the children to crash every time you make a change to it. So with private, this provides the ultimate protection to the data members and the methods of the private class. This procedure is implemented by class to encapsulate the methods and members. So very important. We have private and we have protected and we have public. The more access you want other pieces of the software code to have and other programmers to have, the more public you want to make it. And of course the default is public. Now, one of the common workarounds for this, because you're going to have protected data, but you still want it to be used by the subclasses, is to create what they call like a get or a, and we'll do it up here. We'll go ahead and do a private integer x equals 5. And then instead of, on your inheritance, instead of having it call it from the child, we might have a get thing or a get thing. We might have a public, it's going to return an integer, and we might have it say get x. And this simply just return x. And what this means is that when we have something simple like this where it just does a return x, I can go back into my child here, and instead of print x, we'll do x dot get x. And we'll go ahead and print this out. Or yeah, something simple with that. We'll go ahead and do a system print line on this. And when we run this, you'll see it come up. It's going to recompile, and we get our 5. What's happening here is now I've created underneath the parent private information. You don't know what's going on with it. It's protected. You might have a procedure that's protected. In this case, we had the print procedure, and then we access it from the public. And this could have easily have been, instead of, maybe we'll just call it public void public print. Kind of a goofy way of doing the code. There we go. And then it could go in here and access our print. And so we can actually still access this print variable up here by wrapping it in kind of a get or a public function. This allows us to protect whatever code is going on in the parent class, so it can't be messed up, it can't be accessed indirectly, it has to go through the right processes. And so when we get to the child on here, the child can then still has the public processes, but all the other information is protected and is private. It's really important to remember that private right there. This brings us to super keyword. And when we talk about the super keyword eliminates the confusion between parent class method and subclass method. Super keyword is implemented to access a method or constructor that is defined in the parent class. So back in Eclipse, we'll go under parent, and we'll take this, we're going to take the private out of there, so now we have an integer 5. And we'll go ahead and just remove the print because we're not going to do that in the parent. Oops, and the public. There we go. And so let's create a parent that just has one piece of information. It has an integer x equals 5. And then we're going to go to the child, and let's go ahead and add in here integer x equals 10. And these are, by default, they're public. We haven't set anything on here telling it what it is. And so what I'd like to do is we'd like to go ahead and create a, oops, one more thing, there we go. Create a procedure here, and we'll just call this void capital print. And it's just going to be a system out print line. And this is what I want you to notice is we're going to print out x and super x. So we have the child class x and we have the parent class super x. And if we come down here and we do x dot print, don't forget my semicolon, add a couple spaces in here to make it look nicer when we print it. And we'll go ahead and run this. And you can see that the child class prints 10 and the parent class is 5. And so this way you can actually store different information depending on what it is you're working on and what you're doing. And that's where this super comes in. You can see right here where the super underneath the class and the print module. Now you can't just put it in down here under print. And we can explore what that looks like. If I just take this and I go ahead and highlight it. And let's say I wanted to just, instead of doing xprint, it's going to come up right here. And right off the bat, you see the super.x. I can do x.super.x, and it's still going to give me an error right here. It has to be underneath a procedure in the actual class and not under the main. This brings us to types of inheritance. And there's 4 main types. We have single inheritance, which we've already pretty much looked at, but we'll go back over. We have multi-level inheritance. We have hierarchical inheritance and hybrid inheritance. Let's go ahead and just start with the single inheritance. Single inheritance consists of one parent class and one child class. Here, child class inherits parent class methods and data members. And let's go ahead and create a new class up here, just to change it up and keep it interesting. New class. And we'll call this one student. And under the student, we'll have a simple setup. We'll just do an enrolled, and it'll say enrolled in Simplilearn. There we go. So there's our class student. And then we'll create another class. We'll do it as because we have our student, our base student. And then we'll call this one new class. And we'll call this one computers. There we go. So he's enrolled, finish. And for computers, let's go ahead and put in a print line here. And we'll put down studying computers. And we want to go ahead and do the extends student. So it's a student studying computers, subclass computers. And this would all look familiar because we've been doing this for, a lot of the other setups. This is your basic inheritance. And we'll change that from enrolled to studies. And then let's go ahead and put a main in here so we can actually run it. And we have our P enrolled, which comes from our parent class, and our P studies, which comes from the child, or the one that inheritance it, the extends for student. And let's go ahead and run that. There we go, run. And you can say enrolled in Simplilearn studying computers. And then we can go on to the next setup. And this is where we look at multi-level inheritance. It is also a parent-child inheritance relation, but the difference is the child class is inherited by another child class. This is the basic structure of most programming languages right here. You have an object, you have all the different things under the object, and it gets all the way down to whether it's an array you're working with, whether even a class is a subchild that goes all the way up to the object. And we can simply do that in our code in Eclipse. And we'll just go ahead and add a new class in there. We'll call this one Java. There we go. Oops, Java. And under Java, we want to go ahead and create some of the similar stuff. And then I want to go back to my student. I took out the main and student just because I don't want it to run the main in there. And in here, we're going to have system out. We're going to have, instead of studying computers, focus on Java, which is what we're doing right now. And maybe we'll call this classroom. And then we can come down here and we have our P equals new computers. Well, instead of new computers, we want our Java. And it's going to be a Java object. And we need to put our extends in up here. Extends, in this case we came from computers. So there's our initial thing. And then we have our last print in here. And of course, if we run this now, we'll see that it should, if I did everything correctly, come up and say, enrolled in Simplilearn, studying computers, focus on Java. And we have the enrolled, which is the parent to computers. And then we have under computers, well, we have student, then computers, and then Java. And so each one of these classes just cascades all the way down. And this is your multi-level from your class A to class B to class C. And if you can have multi-level inheritance, we can also have a hierarchical inheritance where your parent-child relationship, the only difference is here multiple child classes inherit from one parent class. And that is pretty, we'll do another class here. If you remember correctly, we had student, computers. Maybe from student we'll have, instead of computers, we'll have project management. Project management. So you're studying your IDLE and all your other classes in there for Cascade and for doing agile programming. And in here we can do that. And it's just the same as we did before. We just have a second child coming in from here. And so this would go ahead and extends student. And of course, whatever subcategory you have one in here for running this. And so for here, we'd have like our void studies. In this case, instead of studying computers, we're studying project management. One of the other wonderful classes that is taught from the Simplilearn team. And we'll go and run that, and you can see right here we have computers. Oops, of course, instead of computers, I meant to do project management. There we go. And we have to also initiate it as a new. And then when we run here, we can see this. We're enrolled in Simplilearn and we're studying project management. And then finally there is the hybrid. The name itself explains it to us. The hybrid inheritance can be a combination of any of the three types of inheritance supported in Java. And so maybe we already saw that because we have our A and our B. If we flip back on over to our Eclipse, we have our student. Our student now has a computers, project management. So there's our hierarchical, and then they're mixed because we also have the Java, which is an extension of the computer. And so we have multiple layers there. So one of the issues that comes up with inheritance in classes is what they call the diamond problem. And in the diamond problem, the Java programming language does not support multiple inheritance as it ends up with serious ambiguity. And that is where we have D, which inherits from both B and C, which might both inherit from A. This is the diamond factor because as you start tracking your supers going up, which one are you actually looking at, B or C or A? And that's why they call this the diamond problem. It comes up more than you would think. You get very complicated structures and you realize, oh, I need to have both sets of instructions come down to whatever I'm working on. And you can see where that can become a problem. Let us take a look at is a relation and has a relation. Now these, I mean, they're vocabulary, but they're more of a concept, understanding how things fit together. And so when we talk about is a relation, when a class inherits methods and members from a different class, then the relationship is said to be is a relation. Examples, orange is a fruit. And let's just jump back on over here and we'll make a new class. And we'll call this class customer. So we're going to have our customers. Oops. There we go, if I can remember how to type. So we have a class customer, and I've gone ahead and our team in the back went ahead and prepped this for us. Let's just take a quick look though. We got public string name, so it's accessed publicly. If you leave this out, it'll automatically be public because that's the default. And then we have our customer and the string, which is a name, and a string is a city. And then when you do a customer and you send it the name and the city, it will do this name equals name and this city equals city. We could have easily done this private. We have a call into it to create it. So it wouldn't really matter too much whether we did it private or public. I would actually be more likely to do it private. And for this example, we'll go ahead and create another class, and we'll call this store. We'll have our store class. We have customers and we have a store. And then we'll go ahead and set up in here. And this time we did do a private. We're going to create a list of customers, and then the store list coming down, and then this customers, and public list customers. A quick look at this is we did make this one private, which is nice because now it can't be accessed externally except from store. And then store has the public list customers, so we can send it a list of customers, and then it go ahead and returns the customers from that list. And then when we add it to the store, it sets the customers in the store. This dot customers equals customers. One of the reasons we have the error lines in here is I haven't compiled it, so it doesn't see the customers are part of our package. And we'll get to that in just a moment here. And then let's go ahead and create another class. We'll call this is a relation, since that's what we're working on. And here's our is a relation setup. And we're just going to put this as the main, so you have your main in there. And then we went ahead and prepared a series of customers. And we'll just call it customer C1 equals a new customer, customer C2 equals a new customer. And we're just creating a list here. That's all we're doing. And if we're going to have a list, then we need to go ahead and create a list of customers. And we'll just do that with a simple list setup. And then we got to add those customers into the list. So let's go ahead and do that. So breaking this down, we have customer 1, which is Raju, Bangalore, Shiva, Hyderabad, Sachin, Mumbai, and so on. And then we just created a list of customers, a new array of lists, and then we add in each of those customers. So now we have a nice list of all our different customers in here. And then we want to go ahead and create our store. And we'll put in store, and it'll be a fruit smoothies franchise. I put down fruit smoothies franch. Maybe that's not a good abbreviation because you might think it's a French instead of franchise. But it'll be a new store. And then we have our new store, which is, in this case, we're going to put in that new store customers. And if you remember, we went back here into store. Let me just flip back on over there. It's going to take that list of customers and put that into this customer. So now the private list is going to equal that list of customers. And then of course we can come in here and we do public list, it's going to return that list of customers. So we have public assets here, and this store, you can add public at the beginning. We'll go ahead and do that just to make it clear. Is it public? Is what's going to run on there. And let's go back into our is a relation. And flip back to store. I'm going to go ahead and just change this to customer list. So here's our list, customer list, and it's going to return the customers from this selection, from our private variable. So we come into here, we can come down here and we'll go ahead and put that in there. We'll do a loop on this. We'll have a list customer, and we're going to create a list of our customers from our Fruit Smoothies franchise, and we'll get the customer list from there. And then for a customer in the for customer CST in customer, we're going to go ahead and just print that name out there. Now at this point, if you have an error showing up here under list and also underneath array list, depending on how you did your install, you might have to go ahead and import those, your array list, from your Java utility. Not a big deal. And then once we go ahead and we have this all set up, you'll see here the compiler goes through, and then we have the name of the customer, city, and then it just lists the customers going down here. So when we talk about our relationship of our Fruit Smoothies franchise and customers, the customers, they are a relationship directly to the French Smoothies franchise. Now, the second idea is it has a relation. And let's go ahead and take a look at that and see how that differs. And we'll go ahead and create a, let's see. We had customers, so let's do, and we'll call this one, we're doing with smoothies, so we'll have flavors, or favorite. We'll do favorite flavors. Favorite flavors for a class, very strange class. And let's see, in favorite flavors, we'll go ahead and give it a couple things to look at. We'll have a private string and a name, and then we'll have a public string get flavor. There we go, and that's just going to return return. We'll just have that return the name of the flavor. There we go. And then we want to go ahead and create one more class, and this class we'll call has a relation. And I'm hoping you're guessing where we're going with this. Let's go ahead and put some code in here to make it work. And let's go back to our favorite flavors and put in a constructor so that we can load the flavors, and then return this name so we can return the flavors. We'll go back into has a relation. And let's just create a customer. We'll call it cust. Our new customer is Toby Marshall from Mumbai. And our favorite flavors are strawberry, banana, and peanut butter. I don't know, it's a strange concoction. And then we run a print line. We're going to print the customer name from customers and the flavors get flavor. And so when we're looking at this, what I want you to be aware of is that neither the flavors nor the customer are in the same class. They're not, it's not an actual relationship, but they have a relationship because we have Toby who happens to like strawberry and peanut butter. And if you remember, just a quick note, we were looking at the diamond problem. You can create a class that then has these two subclasses in. And that's how you go around the diamond problem, is you don't inherit, but you create classes inside the class you're working with.
So, are you ready to take your career to new heights? The demand for full-stack web developers is soaring in today's fast-paced world. And now, Simplilearn presents the perfect opportunity for you to excel in this exciting field with our postgraduate program in full-stack web development. This comprehensive program will equip you with the foundation to build full-stack web applications using the power of Java programming language. From the basics of JavaScript to advanced level concepts like Angular, Spring Boot, Hibernate, JSPs, and MVC, we have got you covered. What else can you expect from this program? This program includes Caltech CTME postgraduate certificate, enrollment in Simplilearn's Job Assist, receive up to 25 CEUs, from Caltech CTME. Simplilearn's Job Assist help you get noticed by the top hiring companies. You'll also get to attend masterclasses from Caltech CTME instructors, live virtual classes led by industry experts, hands-on projects and integrated labs, online convocation by CTME program director, 20 lesson end and 5 phase end project.
What is polymorphism? According to chemistry, the term polymorphism can be defined as the ability of any element or compound to exist in multiple crystalline forms. This is called polymorphism. For example, if you have the carbon atom, it can come out in different forms in coal, graphite, and diamond. What is polymorphism in Java? Similarly, in the terms of Java programming language, polymorphism is defined as the ability of any object in a class to perform a particular task in multiple methods. This is known as polymorphism in Java. We're going to open up our Eclipse editor and we're going to do some animal sounds with cows, cats, and dogs. Just kind of a fun, almost kids-like example of polymorphism. And you can see I already have my inheritance in here. Let's go ahead and create a new package. And we'll call this polymorphism, just to keep it simple. And once we have our polymorphism in there, we're going to go ahead and add a class in. And if you were doing an abstract class, we can label it as abstract because we're not going to directly access it. And we'll call it animal sounds. Maybe we will. We'll see how we load the program up. But we'll call this animal sounds. And let's create a public, it's not going to return anything, but we'll call it sound on here, and we just want to go ahead and have it do a system out print. And with our system out print line, we'll just have it say animals make different sounds. There we go. So yeah, it's really simple and straightforward. We're just going to have it print something out. And if we're going to do that, let's go ahead and just, good thing I didn't make it abstract. Let's go ahead and just test it out and see what it looks like. And we'll do, we'll call it animal main. Animal main. And in here, let's go ahead and test out what we just put together. We'll do our static void main, so it's going to run on here. And we'll create our animal sounds. We'll call it animal, because we don't know what kind of animal this is. We'll call it new animal sounds. And we'll just take that animal, and I like to put it in capitalized, but usually we like to do this lowercase. There we go. And we'll just have our animal dot sound end. And let's go ahead and run this and see what comes out. We can see here animals make different sounds. Okay, that's not too exciting. So let's jump in there and let's say we have, in this case, we're going to add in a couple of different animals. We'll add in a, let's start with a cow. Yeah, why not a cow? So we'll have our cow in here. We'll go ahead and click OK. And now we have our cow class. But a cow doesn't just, it makes different noises, but it actually makes a very clear noise. So we'll go ahead and give the cow a sound. And we'll have the cow say moo moo. And the cow is going to extend. There's our, and we'll put in our extends animal sounds. And then I want to go back here to our animal main. And now we have a class cow. So in our animal main, we want to do cow equals new cow. And once we've created the new cow, we also need to go ahead and have the cow sounds. There we go. And we run this. You can see it comes out here and it says the cow says moo moo. So if we go back to cow, we're just going to do this real quick. And let's say we just take this out of here, the public void sound. And then we're going to go into our animal main and run that. Recompiles. Animals make different sounds because it doesn't know what sound a cow makes. So this is really central to polymorphism, is we're taking something going on in the in one setup that we've brought in and extended from our animal sounds, and we've changed it to the cow says moo moo. And we can also add in multiple animals in here. We'll go ahead and just add in one more animal. We'll call this one, we'll do a dog, why not? So here comes in our dog, and of course we want the dog to actually say something. And we'll have the dog go bow wow, and then we'll go back to our animal main, and we have to create a dog. And we'll say cow, simply dog, dog, uppercase for the class, lowercase for the actual object. And then of course we need the dog to make a sound, so we'll go down here and go dog dot sound. And when we run this, as you expect, it's going to compile it. There we go. Animals make different sounds. The cow says moo moo. The dog says bow wow. Characteristics of polymorphism. The functionality of a method behaves differently in different situations. The behavior of a method is dependent on the data. Polymorphism is mainly used to implement inheritance. As we saw, we did the extends with the animal sounds. Polymorphism is mainly used to implement inheritance. It allows same name for a member of method in a class with different types, which we'll cover briefly in a minute. Polymorphism supports implicit type conversion. Types of polymorphism. There are basically two types of polymorphism that can be occurred in Java programming language. They are mentioned as follows: compile time polymorphism, runtime polymorphism. Compile time polymorphism gets executed during the compilation stage. Here the overloading method gets resolved in compilation stage. So when you saw me run those in Eclipse and I went through the compile time, that's looking at all the different changes we made to those classes. That's what we're talking about here, is during compile time. In method overloading, in Java, the process of method overloading is achieved when a class has two or more methods with same name, but the specific method is selected based on the number of parameters declared. We'll now execute a program based on the functionality of additional operator in a different situation. And let's flip back on over to our Eclipse. So in here, I'm going to go back under the dog, and let me just highlight this. And we're going to do the same thing. So you see right here it says public void sound. So this is identical, public void sound. But instead of sending nothing, we're going to send it a string, and we're going to call it angry. Now at this point, you should note that what if it's a happy dog? I would have to add an if-then. If the string angry said happy, then we'd print happy or something else. But we're just keeping it simple. So we've entered another sound identical to the first, but we've added string angry to it. And this one's going to print out the dog says growl growl. Now if we go back to our animal main, and here's our dog, same sound, but now we're going to add a string in here. And we put that string in here, we'll go ahead and just call it angry. It doesn't really matter what string you put in here because we haven't sorted out what the string means. For now it just says growl growl. It's going to recompile it. So remember, this is a polymorphism during compile time. And here we have it, the dog says growl growl. So the dog says bow wow, and then the angry dog says growl growl. So there's another thing called operator overloading. Operator overloading is not supported in Java. The authors of Java wanted to keep the language less complicated. Explaining operator overloading, it basically is a way of bundling operations into the call statement and user procedures. It's so that it looks like a math on a paper. You have A plus add B plus C kind of thing, and it's all wrapped up in your call to another statement. This just gets confusing, and it really isn't necessary. So the Java developers decided not to put it in there. So runtime polymorphism. In Java programming language, runtime polymorphism gets handled during the program execution stage. Here the overriding method gets resolved in execution. So far we've talked about compile time polymorphism. As you saw in the program we just wrote, when it's compiling, it does the extend and figures out which overload method to use on there. In runtime polymorphism, method overriding, in Java, the method overriding is a procedure where a child class is allowed to implement a specific class that is already provided in the parent class. For runtime compilation code, or polymorphism, we need to go ahead and introduce the super keyword. Now, from inheritance, you should remember that we can look at super from before, but we're going to use it slightly different. It's kind of doing the same thing as when we did the inheritance, but we're doing like what they call an override during runtime. So the term super is a predefined keyword in Java that is used to refer the immediate parent class object or method defined in the program. In this procedure, whenever you create an instance of subclass, then automatically an instance of parent class is also created that will be implicitly referred by the super reference variable. So going back into our animal sounds, let's go in here to dog. And if we add a super dot sound in here, this is going to reference whatever our extend is, because the dog extends animal sounds. And so here's our super dot sound. And if we go ahead and we'll run and compile this, and you can see here that it comes down and it says the dog says growl growl, because that's what we had it system out print line to. And then the super, animals make different sounds. And so if we go back to our animal main, this is what it's calling right here. It's going back into sound under the animal mains and it's printing out or doing whatever it does here. At this point, we usually have it return something so you can look up whatever the original class was using. So getting back to these two setups, whether you're using the super to use a runtime polymorphism, because that's what's happening during runtime, versus compile time polymorphism. During compile time polymorphism, method call is handled by the compiler itself. So the program maybe take a second more to compile, but it runs faster. In the runtime, the method call cannot be handled by compiler in the execution stage. So if you have any errors, it's not going to show up either. During the compile time, we have compile time polymorphism is less flexible as it needs to handle all method calls in compile time. So you really, in runtime polymorphism, it exhibits higher flexibility as the method call gets handled at runtime coming in. The execution period for compile time polymorphism is less. That's what I was just talking about. It compiles it, so the compiling takes maybe a little bit more. But if you're executing the same program over and over and over again, once it's distributed, it's going to run faster. Then, of course, with the runtime polymorphism, the execution period for runtime polymorphism takes longer. It's just a little bit more. Usually in most programs you don't notice this, but if you're executing the same script 1,000 times, suddenly that 0.01 second is a lot more. It suddenly is adding up a second each time it goes through the 1,000 iterations. Then with the compile time polymorphism, integrating the right method call with the right method is done in compile time. And of course, in runtime, integrating the right method call with the right method is done in runtime. Again, that's another delay because it has to figure out what it's doing. It's not already pre-mapped out. And finally, compile time polymorphism occurs during method overloading and operator overloading, where runtime polymorphism occurs during the method overriding. Advantages of polymorphism: programmers' code can be reused via polymorphism. Number one goal of a programmer is to reuse the code as much as possible so you're not reinventing the wheel over and over again. Advantages of polymorphism: supports single variable name for multiple data types, reduces coupling between different functionalities. And some of the disadvantages of polymorphism that can come up is that polymorphism ends up raising performance issues in real time. You can see where as you're loading all these different things, you might end up creating loops you didn't know you were doing. Polymorphism reduces readability of the code. Sometimes your actual code, everything you look at in Java is polymorphism, all based on a primary object. So you could have a very complicated setup, and then it actually is very easy to read when you actually put your final variable in there. But when you're going through lines and lines of code, it can be really hard to figure out what's going on as you loop through all these different inherited modules or classes. Programmers find polymorphism difficult to implement. It just depends. The more you use it, the easier it is.
Example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs And whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into two different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into two different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do the exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface, and in the get result, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type, and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number dot poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate dot get result. Now this get result will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll. And this time the numbers.poll is going to pick up 3. So 3 will be picked up here. And then the current value of result, which is already 9, 4 plus 5 was 9. The current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized and we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. So it is going to execute 27 by 2 and whatever value it gets, it is going to store the result value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through, because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27, and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays, or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it, and then we fetch the next value in the numbers queue, and then we call the get result based on the expression, and whatever result we get from the get result, we store it back into the rest variable. So we keep updating the rest variable at every step. That's the reason the result of 4 plus 5 gets stored in the rest, and next time you are calling the get result for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts.
Well, that's a wrap on the basics of Java programming. We hope you found this video informative and helpful. By now, you should understand the most basic concept of Java programming and the reasons to master this programming language in 2023. If you are interested in learning more about different technologies, plenty of resources are available at Simplilearn. You can also check out our website for more information on different certifications. Thank you for watching, and we'll see you next time. Until then, keep learning and stay safe.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.